which have been especially powerful in number theory recently. There's a book, for instance, by Edward Frankel about love and math.
Oh yeah, that book's great. I recommend it highly. It's partially accessible, but there's a nice audiobook that I listened to while running an exceptionally long distance, like across the San Francisco bridge. And there's something magic about the way he writes about it, but some of the group theory in there is a little bit difficult.
And that's the problem with any of these things. To kind of really say what's going on in this and make it accessible is very hard. He, in this book and elsewhere, I think, takes the attitude that kinds of mathematics he's interested in and that he's talking about provide kind of a grand unified theory of mathematics. They bring together geometry and number theory and representation theory, a lot of different ideas in a really unexpected way. But I think, to me, the most fascinating thing is if you look at the kind of grand unified theory of mathematics he's talking about, and you look at the physicists' kind of ideas about unification, it's more or less the same mathematical objects are appearing in both. So it's, I think we're seeing a really strong indication that, the deepest ideas that we're discovering about physics and some of the deepest ideas that mathematicians are learning about are intimately connected.
Is there something, like if I was 5 years old and you were trying to explain this to me, is there ways to try to sneak up to this, to what this unified world of mathematics looks like? You said number theory, you said geometry, words like topology. What does this universe begin to look like? What should we imagine in our mind? Is it a three-dimensional surface? Or is it trying to say something about it? Is it triangles and squares and cubes? Like what are we supposed to imagine in our minds? Is this natural number? What's a good thing to try for people that don't know any of these tools except maybe some basic calculus and geometry from high school that they should keep in their minds as to the unified world of mathematics that also allows us to explore the unified world of physics?
And what I find kind of remarkable about this is the way in which we've discovered these ideas, but they're actually quite alien to our everyday understanding. We grow up in this three-spatial dimensional world, and we have intimate understanding of certain kinds of geometry and certain kinds of things. But these things that we've discovered in both math and physics are that they're not at all close to have any obvious connection to kind of human everyday experience. That they're really quite different. And I can say some of my initial fascination with this when I was young and trying to learn about it was actually exactly this kind of arcane nature of these things. It was a little bit like being told, well, there are these kind of some semi-mystical experience that you can acquire by a long study and whatever, except that it was actually true. There was actually evidence that this actually works. So I'm a little bit wary of trying to give people that kind of thing because I think it's mostly misleading. But one thing to say is that that geometry is a large part of it, and maybe one interesting thing to say that's about most recent ideas is that when we think about the geometry of our space and time, it's kind of three spatial and one time dimension. Physics is in some sense about something that's kind of four-dimensional in a way. And a really interesting thing about some of the recent developments in number theory have been to realize that these ideas that we were looking at naturally fit into a context where your theory is kind of four-dimensional. So geometry is a big part of this, and we know a lot and feel a lot about 3-dimensional geometry.
So wait a minute. So we can at least rely on the 4 dimensions of space and time and say that we can get pretty far by working that in those 4 dimensions. I thought you were going to scare me that we're going to have to go to many more dimensions than that.
And my point of view, which goes against a lot of these ideas about unification, is that no, this is really everything we know about really is about 4 dimensions. And that you can actually understand a lot of these structures that we've been seeing in fundamental physics and in number theory, just in terms of 4 dimensions. That it's in some sense I would claim has been kind of a mistake that physicists have made for decades and decades to try to go to higher dimensions, to try to formulate a theory in higher dimensions, and then you're stuck with the problem: how do you get rid of all these extra dimensions? Because we only ever see anything in 4 dimensions.
That kind of thing leads us astray, I think. So creating all these extra dimensions just to give yourself extra degrees of freedom. Yeah, isn't that the process of mathematics, is to create all of these trajectories for yourself, but eventually you have to end up with like a final place. But it's okay to sort of create abstract objects on your path to proving something.
Yeah, certainly. But from mathematicians' point of view, in the kinds of mathematicians also are very different than physicists, in that we like to develop very general theories. We like to, if we have an idea, we want to see what's the greatest generality in which you can talk about it. So from the point of view of most of the ways geometry is formulated by mathematicians, it really doesn't matter. It works in any dimension. It can do 1, 2, 3, 4, any number. There's no particular, for most of geometry, there's no particular special thing but 4. But and anyway, but physicists have been trying to do over the years is try to understand these fundamental theories in a geometrical way, and it's very tempting to kind of just start bringing in extra dimensions and using them to explain the structure. But typically this kind of founders, because you just don't know. You end up not being able to explain why we only see 4.
It is nice in the space of physics that, like if you look at Fermat's last theorem, it's much easier to prove that there's no solution for n equals 3 than it is for the general case. And so I guess that's the nice benefit of being a physicist, is you don't have to worry about the general case, because we live in a universe with n equals 4 in this case.
Yeah, physicists are very interested in saying something about specific examples. I find that interesting. Even when I'm trying to do things in mathematics, and I'm trying to even teaching courses and mathematics students, I find that I'm teaching them in a different way than most mathematicians, because I'm very often very focused on examples, on what's kind of the crucial example that shows how this powerful new mathematical technique, how it works, and why you would want to do it. And I'm less interested in kind of proving a precise theorem about exactly when it's going to work and when it's not going to work.
Do you usually think about really simple examples, like both for teaching and when you try to solve a difficult problem? Do you construct like the simplest possible examples that captures the fundamentals of the problem and try to solve it?
Yeah, exactly. That's often a really fruitful way to, if you've got some idea, you just kind of try to boil it down to what's the simplest situation in which this kind of thing is going to happen, and then try to really understand that. And that is almost always a really good way to get insight.
Do you work with paper and pen, or like, for example, for me, coming from the programming side, if I look at a model, if I look at some kind of mathematical object, I like to mess around with it, sort of numerically. I just visualize different parts of it, visualize however I can. So most of the work is like neural networks, for example. Yes, you try to play with the simplest possible example, and just to build up intuition by, any kind of object has much variables in it. And you start to mess around with them in different ways and visualize in different ways to start to build intuition. Or do you go the Einstein route and just imagine, like, everything inside your mind, and sort of build like thought experiments, and then work purely on paper and pen?
Well, the problem is kind of stuff that I'm interested in is you rarely can kind of, it's rarely something that is really kind of, or even the simplest example, you can kind of see what's going on by looking at something happening in 3 dimensions. There's generally the structures involved are either they're more abstract, or if you try to kind of embed them in some kind of space where you could manipulate them in some kind of geometrical way, it's going to be a much higher dimensional space.
So even simple examples, embedding them into 3-dimensional space, you're losing a lot.
Yeah, but to capture what you're trying to understand about them, you have to go to 4 more dimensions. So it starts to get to be hard as much as just kind of think about things in your mind. And I often use pad and paper, and often in my office, I often use the blackboard. Um, and you are kind of drawing things, but they're really kind of more abstract representations of how things are supposed to fit together. And they're not really, unfortunately, not just kind of something really living in 3 dimensions, or you can.
Are we supposed to be sad or excited by the fact that our human minds can't fully comprehend the kind of mathematics you're talking about? I mean, what do we make of that? I mean, to me, that makes me quite sad. It makes it seem like there's a giant mystery out there that we'll never truly get to experience directly.
It is kind of sad how difficult this is. I mean, I would put it in a different way that most questions that people have about this kind of thing, you can give them a true answer and really understand it, but the problem is one more of time. It's like, yes, I could explain to you how this works, but you'd have to be willing to sit down with me and work at this repeatedly for for hours and days and weeks, and it's just going to take that long for your mind to really wrap itself around what's going on, and that does make things inaccessible, which is sad. But it's just kind of part of life that we all have a limited amount of time, and we have to decide what we're gonna spend our time doing.
Speaking of limited amount of time, we only have a few hours, maybe a few days together here on this podcast. And let me ask you the question of amongst many of the ideas that you work on in mathematics and physics, which is the most beautiful idea, or one of the most beautiful ideas, maybe a surprising idea? And once again, unfortunately, the way life works, we only have a limited time together to try to convey such an idea.
Okay, well, let me just tell you something which I attempted to kind of start trying to explain what I think is this most powerful idea that brings together math and physics, ideas about groups and representations and how it fits in quantum mechanics. But in some sense, I wrote a whole textbook about that, and I don't think we really have time to get very far into it. So,
well, can I actually, on a small tangent, you did write a paper towards a grand unified theory of mathematics and physics. Maybe you could step there first. What is the key idea in that paper?
Well, I think we've kind of gone over that. I think that the key idea is what we were talking about earlier, that just kind of a claim that if you look and see have been successful ideas in unification in physics over the last 50 years or so, and what's been happening in mathematics, and the kind of thing that Frankel's book is about, that these are very much the same kind of mathematics. And so it's kind of an argument that there really is, you shouldn't be looking to unify just math or just fundamental physics, but taking inspiration for looking for new ideas in fundamental physics, that they are going to be in the same direction of getting deeper into mathematics, looking for more inspiration in mathematics from these successful ideas about fundamental physics.
Could you put words to sort of the disciplines we're trying to unify? So it's like number theory. Are we literally talking about all the major fields of mathematics? So it's like the number theory, geometry, so the differential geometry, topology.
Yeah. So one name for this that this is acquired in mathematics is the so-called Langlands program, and so this started out in mathematics. Robert Langlands kind of realized that a lot of what people were doing it was starting to be really successful in number theory in the 60s. So that this actually was, anyway, that this could be thought of in terms of these ideas about symmetry in groups and representations, and in a way that was also close to some ideas about geometry. And then more later on in the 80s and 90s, there was something called geometric Langlands, that people realized that you could take what people have been doing in number theory and Langlands and just forget about the number theory and ask, what is this telling you about geometry? And you get some new insights into certain kinds of geometry that way. So that's kind of the name for this area, is Langlands and geometric Langlands. And just recently, in the last few months, there's kind of a really major paper that appeared by Peter Schulze and Laurent Fargue, where they, made, some serious advance in trying to understand a very much kind of a local problem of what happens in number theory near a certain prime number, and they turn this into a problem of exactly the kind of geometric line-less people have been doing, these kind of pure geometry problem. And they found by generalizing the mathematics, they could actually reformulate it that way, and it worked perfectly well.
Well, one of the things that makes me sad is, I'm a pretty knowledgeable person, and then at least I'm in the neighborhood of like theoretical computer science, right? And it's still way out of my reach. And so many people talk about, like Langdon, for example, is one of the most brilliant people in mathematics, and just really admire his work. And I can't. It's like almost I can't hear the music that he composed, and it makes me sad.
Yeah. Well, I mean, I think that unfortunately it's not just you. I think even most mathematicians really don't actually understand what this is about. I mean, the group of people who really understand all these ideas, and so for instance, this paper of Schultz and Farr that I was talking about, the number of people who really actually understand how that works is, anyway, very, very small. And so I think even you find if you talk to mathematicians and physicists, even they will often feel that there's this really interesting sounding stuff going on, which I should be able to understand. It's kind of in my own field I have a PhD in, but it still seems pretty clearly far beyond me right now.
Well, if we can step into back to the question of beauty, is there an idea that maybe is a little bit smaller that you find beautiful in the space of mathematics or physics?
There's an idea that I kind of got a physics PhD and spent a lot of time learning about mathematics, and I guess it was embarrassing that I hadn't really actually understand this very simple idea until I kind of learned it when I actually started teaching math classes, which is maybe that maybe there's a simple way to explain kind of the fundamental way in which algebra and geometry are connected. So you normally think of geometry as about these spaces and these points, and you think of algebra as this very abstract thing about these abstract objects that satisfy certain kinds of relations. You can multiply them and add them and do stuff, but it's completely abstract and there's nothing geometric about it. But the kind of really fundamental idea is that unifies algebra and geometry is to think whenever anybody gives you what you call an algebra, that's some abstract thing of things that you can multiply and add, that you should ask yourself, is that algebra the space of functions on some geometry? So one of the most surprising examples of this, for instance, is a standard kind of thing that seems to have nothing to do with geometry is the integers. So that you can multiply them and add them. It's an algebra, but it seems to have nothing to do with geometry. But it turns out, but if you ask yourself this question and ask, are integers? You think if somebody gives you an integer, can you think of it as a function on some space, on some geometry? And it turns out that yes, you can. And the space is the space of prime numbers. And so what you do is if somebody gives you an integer, you can make a function on the prime numbers by just, at each prime number taking that integer modulo that prime. So if you say, I don't know, if you give it 10, 10, and you ask what is its value at 2, well, it's 5 times 2, so mod 2, it's 0. What is its value at 3? Well, it's 9 plus 1, so it's 1 mod 3. So it's 0 at 2, it's 1 at 3. You can kind of keep going. And so this is really kind of a truly fundamental idea. It's at the basis of what's called algebraic geometry, and it just links these two parts of mathematics that look completely different. And it's just an incredibly powerful idea, and so much of mathematics emerges from this kind of simple relation.
So you're talking about mapping from one discrete space to another. Just for a second, I thought perhaps mapping like a continuous space to a discrete space, like a function over a continuous space.
But you can take, if somebody gives you a space, you can say, well, let's and this is part of the same idea. Part of the same idea is that if you try and do geometry, and somebody tells you here's a space, that what you should do is you should say, wait a minute, maybe I should be trying to solve this using algebra. And so if I do that, the way to start is you give me the space, I start to think about the functions of the space. Okay, so for each point in the space, I associate a number. I can take different kinds of functions and different kinds of values, but basically functions on the space. So what this insight is telling you is that if you're a geometer, often a way to work is to change your problem into algebra by changing your space. Stop thinking about your space and the points in it, and think about the functions on it. And if you're an algebraist and you've got these abstract algebraic gadgets that you're multiplying and adding, say, wait a minute, are those gadgets? Can I think of them in some way as a function on the space? What would that space be? What kind of functions would they be? And that going back and forth really brings these two completely different looking areas of mathematics together.
Do you have particular examples where it allowed to prove some difficult things by jumping from one to the other? Is that something that's a part of modern mathematics, where such jumps are made?
Oh yeah, it's just kind of all the time. Much of modern number theory is kind of based on this idea. But and when you start doing this, you start to realize that you need, what simple things on one side of the algebras, start to require you to think about the other side, about geometry, in a new way. You have to kind of get a more sophisticated idea about geometry. Or if you start thinking about the functions on a space, you may need a more sophisticated kind of algebra. But in some sense, much or most of modern number theory is based upon this move to geometry, and there's also a lot of geometry and topology is also based upon change. If you want to understand the topology of something, you look at the functions, you do Durham cohomology, and you get the topology.
Well, let me ask you then the ridiculous question. You said that this idea is beautiful. Can you formalize the definition of the word beautiful? And why is this beautiful? Well, first, why is this beautiful? Second, what is beautiful?
And I think there are many different things you can find beautiful for different reasons. I think that in this context, the notion of beauty, I think, really is just kind of an idea is beautiful if it packages a huge amount of kind of power and information into something very simple. So in some sense, you can almost kind of try and measure it in the sense of, what are the implications of this idea? What non-trivial things does it tell you? Versus, how simply can you express the idea? So
the level of compression, correlates with beauty.
Yeah, that's one aspect of it. And so you can start to tell that an idea is becoming uglier and uglier as you start kind of having to, it doesn't quite do what you want, so you throw in something else to the idea, and you keep doing that until you get what you want. But that's how you know you're doing something uglier and uglier, when you have to kind of keep adding in more into what was originally a fairly simple idea, and making it more and more complicated to get what you want.
Okay, so let's put some philosophical words on the table and try to make some sense of them. One word is beauty, another one is simplicity, as you mentioned, another one is truth. So, do you have a sense, if I give you two theories, one is simpler, one is more complicated, do you have a sense of which one is more likely to be true, to capture deeply the fabric of reality? The simple one or the more complicated one?
I think all of our evidence and what we see in the history of the subject is the simpler one, though often it's a surprise. It's simpler in a surprising way, but that we just the kind of best theories we've been coming up with are ultimately, when properly understood, relatively simple, and much simpler than you would expect them to be.
Do you have a good explanation why that is? Is it just because humans want it to be that way? Or we just ultra biased and we just kind of convince ourselves that simple is better because we find simplicity beautiful? Or is there something about our actual universe that at the core is simple?
My own belief is that there is something about a universe that's simple, and I was trying to, there is some kind of fundamental thing about math, physics, and all this picture, which is which is in some sense simple. It's true that it's of course true that our minds are very limited and can certainly do certain things and not others. So it's in principle possible that there's some great insight. There are a lot of insights into the way the world works, which aren't accessible to us because that's not the way our minds work. We don't know what we're seeing. This kind of simplicity is just because that's all we ever have any hope of seeing. But
So there's a brilliant physicist by the name of Sabine Hassenfelder who both agrees and disagrees with you, or I suppose agrees that the final answer will be simple.
Yeah.
But simplicity and beauty leads us astray in the local pockets of scientific progress. Do you agree with her disagreement? Do you disagree with her agreement? And agree with the agreement.
Anyway, yes, I thought it was really fascinating reading your book, and anyway, I was finding disagreeing with a lot, but then at the end when she says yes, when we actually figure this out, it will be simple, and okay, so we agree in the end.
Does beauty lead us astray, which is the core thesis of her work in that book?
I guess I do disagree with her on that so much. I don't think, and especially, I actually fairly strongly disagree with her about sometimes the way she'll refer to math. And so the problem is, if physicists and people in general just refer to it as math, and they're often meaning that what I would call math, which is the interesting ideas of math, but just some complicated calculation. And so I guess my feeling about it is more that it's very. The problem with talking about simplicity and using simplicity as a guide is that it's very easy to fool yourself. And, it's very easy to decide to fall in love with an idea. You have an idea that you think, oh, this is great, and you fall in love with it. And like any kind of love affair, it's very easy to believe that the object of your affections is much more beautiful than others might think, and that they really are. And that's very, very easy to do. So if you say, I'm just going to pursue ideas about beauty and this and mathematics and this, it's extremely easy to just fool yourself, I think. And I think that's a lot of what the story she was thinking of about where people have gone astray. That I would argue that it's more people. It's not that there was some simple, powerful, wonderful idea which they found and it turned out not to be useful, but it was more that they kind of fooled themselves that this was actually a better idea than it really was. It was simpler and more beautiful than it really was. There's a lot of the story.
I see. So it's not that simplicity of beauty leads us astray; it's just people are people, and they fall in love with whatever idea they have, and then they leave narratives around that idea, or they present it in such a way that emphasizes the simplicity and the beauty.
Yeah, that's part of it. But the thing about physics that you have is that what really can tell it. If you can do an experiment and check and see if nature is really doing what your idea expects, that you do in principle have a way of really testing it. And it's certainly true that if you thought you had a simple idea and that doesn't work, and you go out and do an experiment, and what actually does work is maybe some more complicated version of it. That can certainly happen, and that can be true. I think her emphasis is more that I don't really disagree with, is that people should be concentrating on when they're trying to develop better theories more on self-consistency, not so much on beauty, but not is this idea beautiful, but is there something about theory which is not quite consistent, and then use that as a guide that there's something wrong there which needs fixing, and so I think that part of her argument, I think we're on the same page about.
What is consistency and inconsistencies? Or what exactly? Do you have examples in mind?
Well, it can be just simple inconsistency between theory and an experiment. So we have this great fundamental theory, but there are some things that we see out there which don't seem to fit in it, like dark energy and dark matter. But if there's something which you can't test experimentally, I think she would argue, and I would agree, that, for instance, if you're trying to think about gravity and how are you going to have a quantum theory of gravity, you should kind of be, test any of your ideas with kind of a thought experiment. Does this actually give a consistent picture of what's going to happen, of what happened in this particular situation or not?
So this is a good example. You've written about this. Since quantum gravitational effects are really small, super small, arguably unobservably small, should we have hope to arrive at a theory of quantum gravity somehow? What are the different ways we can get there? You mentioned that you're not as interested in that effort because basically, yes, you cannot have ways to scientifically validate it given the tools of today.
I've actually, I've over the years certainly spent a lot of time learning about gravity and about attempts to quantize it, but it hasn't been that much in the past the focus of what I've been thinking about. But I mean, my feeling was always, as I think Sabina would agree, that one way you can pursue this if you can't do experiments is just this kind of search for consistency. It can be remarkably hard to come up with a completely consistent model of this in a way that brings together quantum mechanics and general relativity. And that's, I think, kind of been the traditional way that people who have pursued quantum gravity have often pursued, where we have the best route to finding a consistent theory of quantum gravity. And string theorists will tell you this. Other people will tell you it's kind of what people argue about. But the problem with all of that is that you end up, the danger is that you end up with that everybody could be successful. Everybody's program for how to find a theory of quantum gravity, ends up with something that is consistent. And so, in some sense, you could argue this is what happened to the string theorists. They solved their problem of finding a consistent theory of quantum gravity, but they found 10 to the 500 solutions. So, if you believe that everything they would like to be true is true, well, okay, you've got a theory, but it ends up being kind of useless because it's just one of essentially infinite number of things which you have no way to experimentally distinguish. And so this is just a depressing situation. But I do think that there is so again, I think pursuing ideas about more about beauty and how can you integrate and unify these issues about gravity with other things we know about physics, and can you find a theory where these fit together in a way that makes sense and hopefully predict something that's much more promising.
Well, it makes sense, and hopefully, we'll sneak up onto this question a bunch of times because you kind of said a few slightly contradictory things, which is like, it's nice to have a theory that's consistent, but then if the theory is consistent, it doesn't necessarily mean anything. So, like,
it's not enough.
It's not enough, and that's the problem. So it's like it keeps coming back to, okay, there should be some experimental validation. So, okay, let's talk a little bit about string theory. You've been a bit of an outspoken critic of string theory. Maybe one question first to ask is, what is string theory? And beyond that, why is it wrong? Or rather, as the title of your blog says, not even wrong.
Okay. Well, one interesting thing about the current state of string theory is that I'd argue it's actually very, very difficult at this point to say what string theory means. If people say they're string theorists, what they mean and what they're doing is kind of hard. It's hard to pin down the meaning of the term. But the initial meaning, I think, goes back to there was kind of a series of developments starting in 1984 in which people felt that they had found a unified theory of or so-called standard model of all the standard, well-known kind of particle interactions and gravity, and it all fit together into quantum theory, and that you could do this in a very specific way by, instead of thinking about having a quantum theory of particles moving around in space-time, think about quantum theory of kind of one-dimensional loops moving around in space-time, so-called strings. And so instead of one degree of freedom, these have an infinite number of degrees of freedom. It's a much more complicated theory. But you can imagine, okay, we're going to quantize this theory of loops moving around in space-time, and what they found is that you could do this, and you could fairly relatively straightforwardly make sense of such a quantum theory, but only if space and time together were 10-dimensional. And so then you have this problem, again, the problem I referred to at the beginning of, okay, now once you make that move, you've got to get rid of 6 dimensions. And so the hope was that you could get rid of the 6 dimensions by making them very small, and that consistency of the theory would require that these 6 dimensions satisfy a very specific condition called a Calabi-Yau manifold. That we knew very, very few examples of this. So what got a lot of people very excited back in 84, 85 was the hope that you could just take this 10-dimensional string theory and find one of a limited number of possible ways of getting rid of 6 dimensions by making them small, and then you would end up with an effective 4-dimensional theory which looked like the real world. This was the hope. So then there's then a very long story about what happened to that hope over the years. I mean, I would argue in the top part of the book, and its title was that that this ultimately was a failure, that you ended up, that this idea just didn't, there ended up being just too many ways of doing this, and you didn't know how to do this consistently. That it was kind of not even wrong in the sense that you couldn't even you never could pin it down well enough to actually get a real falsifiable prediction out of it that would tell you it was wrong. But it was kind of in the realm of ideas which initially look good, but the more you look at them, they just they don't work out the way you want. They don't actually end up carrying the power that you originally had this vision of.
And yes, the book title is not even wrong. Your excellent blog title is not even wrong. Okay, but there has nevertheless been a lot of excitement about string theory through the decades, as you mentioned. What are the different flavors of ideas that that branched out? You mentioned 10 dimensions. You mentioned loops with infinite degrees of freedom. What other interesting ideas to you that kind of emerged from this world?
Well, yeah, I mean, the problem with talking about the whole subject, and part of the reason I wrote the book, is that it gets very, very complicated. I mean, there's a huge amount, a lot of people got very interested in this, a lot of people worked on it, and in some sense, I think what happened is exactly because the idea didn't really work, that this caused people to, instead of focusing on this one idea and digging in and working on that, they just kind of kept trying new things. And so people, I think, ended up wandering around in a very, very rich space of ideas about mathematics and physics and discovering all sorts of really interesting things. It's just the problem is there tended to be an inverse relationship between how interesting and beautiful and fruitful the idea that they were trying to pursue was and how much it looked like the real world. So there's a lot of beautiful mathematics came out of it. I think one of the most spectacular is what the physicists call two-dimensional conformal field theory. And so these are basically quantum field theories that kind of think of it as one space and one time dimension, which have just this huge amount of symmetry and a huge amount of structure, which just some totally fantastic mathematics behind it. And again, and some of that mathematics is exactly also what appears in the language program. So a lot of the first interaction between math and physics around the language program has been around these two-dimensional conformal field theories.
Is there something you could say about what the major problems are with string theory? So, besides that there is no experimental validation, you've already that a big hole in string theory has been its perturbative definition.
Yeah.
Perhaps that's one. Can you explain what that means?
Well, maybe to begin with, I think the simplest thing to say is, the initial idea really was that, okay, we have this, instead of, what's great is we have this thing that only works, it's very structured and has to work in a certain way for it to make sense, and but then you ended up in 10 space-time dimensions, and so to get back to physics, you had to get rid of 5 of the dimensions, 6 of the dimensions, the bottom line, I would say, in some sense, very simple. But what people just discovered is just there's kind of no particularly nice way of doing this. There's an infinite number of ways of doing it, and you can get whatever you want depending on how you do it. So that you end up the whole program of starting at 10 dimensions and getting to 4 just kind of collapses out of a lack of any way to kind of get to where you want because you can get anything. The hope around that problem has always been that the standard formulation that we have of string theory, which is you can go in by the name perturbative, but it's kind of there's a standard way we know of given a classical theory of constructing a quantum theory and working with it, which is this observation theory that we know how to do, and that by itself just doesn't give you any hint as to what to do about the 6 dimensions. So actual perturbative string theory by itself really only works in 10 dimensions. So you have to start making some kinds of assumptions about how I'm going to go beyond this formulation that we really understand of string theory and get rid of these six dimensions. So kind of the simplest one was the Cotton postulate, but when that didn't really work out, people have tried more and more different things, and the hope has always been that the solution to this problem would be that you would find a deeper and better understanding of what string theory is that would actually go beyond this perturbative expansion, and which would generalize this, and that once you had that, it would solve this problem of it would pick out what to do with the 6 dimensions.
How difficult is this problem? So, if I could restate the problem, it seems like there's a very consistent physical world operating in 4 dimensions. And how do you map a consistent physical world in 10 dimensions to a consistent physical world in 4 dimensions? And how difficult is this problem? Is that something you can even answer? Just in terms of physics intuition, in terms of mathematics, mapping from 10 dimensions to 4 dimensions?
Well, basically, you have to get rid of the 6 dimensions. So there's kind of 2 ways of doing it. One is what we call compactification. You say that there really are 10 dimensions, but for whatever reason, 6 of them are real, but they're so small we can't see them. So you basically start out with 10 dimensions, and what we call make 6 of them not go out to infinity, but just kind of a finite extent, and then make that size go down so small it's unobservable.
That's a math trick. So can you also help me build an intuition about how rich and interesting the world in those 6 dimensions is? So compactification seems to imply that.
Well,
That's very interesting.
Well, no, but the problem is that what you learn if you start doing mathematics and looking at geometry and topology and more dimensions is that, asking the question like, what are all possible 6-dimensional spaces? It's kind of an unnatural question. It's just, it's even kind of technically undecidable in some way. There are too many things you can do with all these. If you start trying to make 1-dimensional spaces, it's like, well, you got a line, you can make a circle, you can make graphs, you can kind of see what you can do. But as you go to higher and higher dimensions, there's just so many ways you can put things together and get something of that dimensionality. So unless you have some very, very strong principle, we're just going to pick out some very specific ones of these 6-dimensional spaces. And there are just too many of them. You can get anything you want. But
so if you have 10 dimensions, the kind of things that happen, say that's actually the fabric of our reality is 10 dimensions. There's a limited set of behaviors of objects, I don't even know what the right terminology to use, that can occur within those dimensions, like in reality. So, what I'm getting at is there some consistent constraints? So, if you have some constraints that map to reality, then you can start saying, dimension number 7 is kind of boring. All the excitement happens in the spatial dimensions 1, 2, 3. And time is also kind of boring. And some are more exciting, or we can use our metric of beauty. Some dimensions are more beautiful than others. Once you have an actual understanding of what actually happens in those dimensions in our physical world, as opposed to sort of all the possible things that could happen.
In some sense, I mean, just the basic fact is you need to get rid of them. You don't see them, so you need to somehow explain them. You have to. The main thing you're trying to do is to explain why we're not seeing them. And so you have to come up with some theory of these extra dimensions and how they're going to behave. String theory gives you some ideas about how to do that, but the bottom line is where you're trying to go with this whole theory you're creating is to just make all of its effects essentially unobservable. So it's not a really it's an inherently kind of dubious and worrisome thing that you're trying to do there. Why are you just
how are you?
adding in all this stuff and then trying to explain why we don't see it? I mean,
This may be a dumb question, but is this an obvious thing to state that
I did.
those 6 dimensions are unobservable, or anything beyond 4 dimensions is unobservable? Or do you leave a little door open to saying the current tools of physics, and obviously our brains are unable to observe them, but we may need to come up with methodologies for observing them. So as opposed to collapsing your mathematical theory into 4 dimensions, or leaving the door open a little bit to, maybe we need to come up with tools that actually allow us to directly measure those dimensions.
Yeah, so you can certainly ask, assume that we've got look at models with 4 dimensions and ask, what would the observable effects? How would we know this? And you go out and do experiments. So, for instance, you have like gravitationally, you have an inverse square law of forces. Okay, if you had 4 dimensions, that inverse square law would change to something else. So you can go and start measuring the inverse square law and say, okay, the inverse square law is working, but maybe if I get it turns out to be actually kind of very, very hard to measure gravitational effects at even kind of somewhat macroscopic distances because they're so small. So you can start looking at the inverse square law and start trying to measure it at shorter and shorter distances and see if there were extra dimensions at those distance scales, you would start to see the inverse square law fail. And some people look for that. Again, you don't see it, but you can. There's all sorts of experiments of this kind. You can imagine which test for effects of extra dimensions at different distance scales, but none of them. I mean, they all just don't work.
Nothing yet.
Yeah, but you can say, but it's just much smaller.
Which, by the way, makes LIGO and the detection of gravitational waves quite an incredible project. Ed Witten is often brought up as one of the most brilliant mathematicians and physicists ever. What do you make of him and his book on string theory?
Well, I think he's a truly remarkable figure. I had the pleasure of meeting him first when he was a postdoc, and he's completely amazing mathematician and physicist, and he's quite a bit smarter than just about any of the rest of us, and also more hardworking. And it's a kind of frightening combination to see how much he's been able to do. And I would actually argue that his greatest work, the things that he's done that have been of just this mind-blowing significance of giving us. He's completely revolutionized some areas of mathematics. He's totally revolutionized the way we understand the relations between mathematics and physics. And most of those, his greatest work is stuff that has little or nothing to do with string theory. For instance, he was actually one of Field's. The very strange thing about him, in some sense, is that he does have a Nobel Prize. But there's a very large number of people who are nowhere near as smart as he is, or don't work anywhere near as hard, who have Nobel Prizes. I think he just had the misfortune of coming into the field at a time when things had gotten much tougher, and nobody really had, no matter how smart you were, it was very hard to come up with a new idea that was going to work physically and get you a Nobel Prize. But he got a Fields Medal for a certain work he did in mathematics, and that's just completely unheard of. For mathematicians to give a Fields Medal to someone outside their field, and physics isn't really, you wouldn't know before he came around. I don't think anybody would have thought that was even conceivable.
So you're saying he came into the field of theoretical physics at a time when, and still today, is you can't get a Nobel Prize for purely theoretical work.
The specific problem of trying to do better than the standard model is just this insanely successful thing, and it kind of came together in 1973, pretty much. And all of the people who kind of were involved in that coming together, many of them ended up with Nobel Prizes for that. But if you look post 1973, pretty much it's a little bit more. There's some edge cases, if you like, but if you look post 1973 at what people have done to try to do better than the standard model, to get a better unified theory, it really hasn't. It's been too hard a problem. It hasn't worked. The theory's too good. So it's not that other people went out there and did it, and not him, and that they got Nobel Prizes for doing it. It's just like no one really, the kind of thing he's been trying to do with string theory is no one has been able to do since 1970.
Is there something you could say about the standard models with the 4 laws of physics that seems to work very well, and yet people are striving to do more? Talking about unification, so on. Why? What's wrong? What's broken about the standard model? Why does it need to be improved?
I mean, the thing that gets most attention is gravity that we have trouble. So you want to, in some sense, integrate what we know about the gravitational force with it, and have a unified quantum field theory that has gravitational interactions also. So that's the big problem everybody talks about. But it's also true that if you look at the standard model, it has these very, very deep, beautiful ideas, but there's certain aspects of it that are very that are, let's just say that they're not beautiful. They're not. You have to make the thing work. You have to throw in lots and lots of extra parameters at various points, and a lot of this has to do with the so-called Higgs mechanism, the Higgs field. That if you look at the theory, everything is. If you forget about the Higgs field and what it needs to do, the rest of the theory is very, very constrained and has very, very few free parameters. Really, very small number. There's a very small number of parameters, and few integers tell you what the theory is. To make this work as a theory in the real world, you need a Higgs field, and it needs to do something. And once you introduce that Higgs field, all sorts of parameters make an appearance. So now we've got 20 or 30 or whatever parameters that are going to tell you what all the masses of things are and what's going to happen. So you've gone from a very tightly constrained thing with a couple parameters to this thing which the minute you put it in, you had to add all these extra parameters to make things work. And so that, it may be one argument as well, that's just the way the world is. The fact that you don't find that aesthetically pleasing is just your problem. Maybe we live in a multiverse, and those numbers are just different in every universe. But another reasonable conjecture is just that, well, this is just telling us that there's something we don't understand about what's going on in a deeper way, which would explain those numbers. There's some kind of deeper idea about where the Higgs field comes from and what's going on, which we haven't figured out yet, and that's what we should look for.
But to stick on string theory a little bit longer, could you play devil's advocate and try to argue for string theory, why it is something that deserves the effort that it got, and still, like if you think of it as a flame, still should be a little flame that keeps burning?
Well, I think the most positive argument for it is all the all sorts of new ideas about mathematics and about parts of physics really emerged from it. So it was a very fruitful source of ideas. And I think this is actually one argument you'll definitely kind of agree with. I'll hear from Witten and from other string theorists that this is just such a fruitful and inspiring idea, and it's led to so many other different things coming out of it that there must be something right about this. And that's okay. Anyway, I think that's probably the strongest thing that they've got.
But you don't think there's aspects to it that could be neighboring to a theory that does unify everything, to a theory of everything? Like it it may not be exactly the theory, but sticking on it longer might get us closer to the theory of everything.
And the problem now really is that you really don't know what it is now. Nobody has ever kind of come up with this non-perturbative theory. It's become more and more frustrating and an odd activity to try to argue with string theorists about string theory because it's become less and less well defined what it is, and it's become actually more and more kind of whether you have this weird phenomenon of people calling themselves string theorists when they've never actually worked on any theory where there are any strings anywhere. So what has actually happened kind of sociologically is that you started out with this fairly well-defined proposal, and then I would argue because that didn't work, people then branched out in all sorts of directions, doing all sorts of things. It became farther and farther removed from that. And for sociological reasons, the ones who kind of started out or were trained by the people who worked on that have now become this string theorists, but it's becoming almost more kind of a tribal denominator than a thing. So it's very hard to know what you're arguing about when you're arguing about string theory these days.
Well, to push back on that a little bit, I mean, string theory is just a term, right? It doesn't, like, you could, like, this is the way language evolves. It could start to represent something more than just the theory that involves strings. It could represent the effort to unify the laws of physics, right?
Yeah.
At high dimensions with these super tiny objects, right, or something like that. I mean, we can sort of put string theory aside. So, for example, in neural networks and basic machine learning, there was a time when they were extremely popular. They became much less popular to the point where if you mention neural networks, you're getting no funding, and you're not going to be respected in conferences. And then once again, neural networks became all the rage about 10, 15 years ago. As it goes up and down, and a lot of people would argue that using terminology like machine learning and deep learning is often misused, overgeneral. Everything that works is deep learning, everything that doesn't isn't, something like that. That's just the way it, again, we're back to sociological things. But I guess what I'm trying to get at is if we leave the sociological mess aside, do we throw out the baby with the bathwater? Is there some, besides the side effects of nice ideas from the headwinds of the world, is there some core truths there that we should stick by in the full, beautiful mess of a space that we call string theory, that people call string theory?
You're right. It is kind of a common problem that how what you call some field changes and evolves and in interesting ways as the field changes. But I mean, I guess what I would argue is the initial understanding of string theory that was quite specific. We're talking about a specific idea of 10-dimensional superstrings compactified as 6 dimensions. That, to my mind, the really bad thing that's happened to the subject is that it's hard to get people to admit, at least publicly, that was a failure, that this really didn't work. And so, de facto, what people do is people stop doing that and they start doing more interesting things. But they keep talking to the public about string theory and referring back to that idea and using that as kind of the starting point and as kind of the place where the whole tribe starts and everything else comes from. So that the problem with this is that having as your initial name and what everything points back to something which really didn't work out, it kind of makes everything. You created this potentially very, very interesting field with interesting things happening, but people in graduate school take courses on string theory and everything and this is what you tell the public, in which you're continually pointing back to this idea which never worked out as your guiding inspiration, and it really kind of deforms your whole way of your hopes of making progress, and that's, I think, the kind of worst thing that's happened in this field.
So there's a lack of transparency, sort of authenticity about communicating the things that failed in the past. And so you don't have a clear picture of like firm ground that you're standing on. Again, those are sociological things. And there's a bunch of questions I want to ask you. So one, what's your intuition about why the original idea failed? So what can you say about why you're pretty sure it has failed?
You know, and the initial idea was, as I tried to explain it, was quite seductive, and that you see why Witten and others got excited by it. It was, you know, at the time it looked like there were only a few of these possible caveats that would work, and it looked like, okay, we just have to understand this very specific model and these very specific six-dimensional spaces, and we're going to get everything. And so it was a very seductive idea, but it just, you know, as people worked more and more about it, it just didn't. They just kind of realized that there are just more and more things you can do with these six dimensions, and you can't. And this is just not going to work.
Meaning, like, it's. I mean, well, what was the failure mode here? Is you could just have an infinite number of possibilities that you could do, so you can come up with any theory you want. You can fit quantum mechanics. You can explain gravity. You can explain anything you want with it. Is that the basic failure mode?
Yes, it's a failure mode of kind of that this idea ended up being essentially empty. That it just ends up not telling you anything because it's consistent with just about anything. And so I mean, there's a conflict. If you try and talk to string theorists about this now, I mean, there's an argument. There's a long argument over this about whether you know, oh, no, maybe there still are constraints coming out of this idea or not, or maybe we live in a multiverse and you know everything is true anyway. So you can different ways you can kind of the string theorists kind of react to this kind of argument that I'm making. So try to hold on to it.
What about experimental validation? Is that a fair standard to hold before a theory of everything that's trying to unify quantum mechanics and gravity?
Yeah, I mean, ultimately, to be really convinced that that some new idea of unification really works, you need some kind of you need to look at the real world and see that this is telling you something true about it. I mean, you know, either telling you that if you do some experiment, go out and do it, you'll get some unexpected result, and that's the kind of gold standard. Or it may be just that, like all those numbers that we don't know how to explain, it will show you how to calculate them. I mean, it can be various kinds of experimental validation, but that's certainly ideally what you're looking for.
How tough is this, do you think, for a theory of everything, not just string theory? So for something that unified gravity, quantum mechanics, the very big and very small, is this, let me ask in one way, is it a physics problem, a math problem, or an engineering problem?
My guess is it's a combination of a physics and a math problem that you really need. It's not really engineering. It's not like there's some kind of well-defined thing you can write down, and we just don't have enough computer power to do the calculation. That's not the kind of problem it is at all. But the question is, what mathematical tools you need to properly formulate the problem is unclear. So one reasonable conjecture is the reason that we haven't had any success yet is just that we're missing certain physical ideas or we're missing certain mathematical tools, or some combination of them, which we need to kind of properly formulate the problem and see that it has a solution that looks like the real world.
Does she need, I guess you don't, but there's a sense that you need both gravity, like all the laws of physics to be operating on the same level. So it feels like you need an object like a black hole or something like that in order to make predictions about. Otherwise, you're always making predictions about disjoint phenomena. Or can you do that as long as the theory is consistent? That doesn't have special cases for each of the phenomena.
Well, your theory should be, if your theory is going to include gravity, or current understanding of gravity is that you should have there should be black hole states, and you should be able to describe black holes in this theory. And just one aspect that people concentrate a lot on is just this kind of questions about if your theory includes black holes like it's supposed to, and it includes quantum mechanics, then there's certain kind of paradoxes which come up. So that's been a huge focus of kind of quantum gravity work has been just those paradoxes.
So stepping outside of string theory, can you just say first at a high level, what is a theory of everything? What does a theory of everything seek to accomplish?
Well, I mean, this is very much a kind of reductionist point of view in the sense that so it's not a theory. This is not going to explain you know anything. It doesn't really this kind of theory of everything we're talking about doesn't say anything interesting, particularly about like macroscopic objects, about what the weather is going to be tomorrow, or things are happening at this scale. But just what we've discovered is that as you look at the universe, it kind of if you kind of you can start breaking it apart into, and you end up with some fairly simple pieces, quanta, if you like, and which are interacting in some fairly simple way. And it's got this. So what we mean by a theory of everything is a theory that describes all the correct objects you need, describe what's happening in the world, and it describes how they're interacting with each other at a most fundamental level. How you get from that theory to describing some macroscopic, incredibly complicated thing is that becomes again more of an engineering problem. You may need machine learning, or you need a lot of very different things to do it. But
Well, I don't even think it's just engineering; it's also science. One thing that I find kind of interesting talking to physicists is a little bit. There's a little bit of hubris. Some of the most brilliant people I know are physicists, both philosophy and just in terms of mathematics, in terms of understanding the world. But there's a kind of either a hubris or what would I call it, like a confidence that if we have a theory of everything, we will understand everything. Like this is the thing to understand, and I would say, and like the rest is details, right? That's the old Rutherford thing. But to me, there's like this is like a cake or something. There's layers to this thing, and each one has a theory of everything. Like at every level, from biology, like how life originates, that itself, like complex systems. Like that in itself is like this gigantic thing that requires a theory of everything. And then there's what in the space of humans, psychology, like intelligence, collective intelligence, the way it emerges among species. That feels like a complex system that requires its own theory of everything. On top of that is things like in the computing space, artificial intelligence systems, like that feels like it needs a theory of everything. And it's almost like once we come up with a theory of everything that explains the basic laws of physics that give us the universe, even stuff that's super complex, like how the universe might be able to originate, even explaining something that you're not a big fan of, like multiverses, stuff that we don't have any evidence of yet, and still we won't be able to have a strong explanation of why food tastes delicious.
Oh yeah, I know. No, anyway, I agree completely. I mean, there is something kind of completely wrong with this terminology of theory of everything. It's not. It's really in some sense a very bad term, very hubristic and bad terminology, because it's not. This is explaining. This is a purely kind of reductionist point of view that you're trying to understand certain very specific kind of things, which in principle, other things emerge from, but to actually understand how anything emerges from this, it's hoped that it can't be understood in terms of this underlying fundamental theory is going to be hopeless in terms of kind of telling you what about this various emergent behavior. And as you go to different levels of explanation, you're going to need to develop new, completely different ideas, completely different ways of thinking. And I guess there's the famous kind of Phil Anderson's slogan is that more is different. Yeah, so it's just yeah. Even once you understand what a couple of things, well, if you have a collection of stuff and you understand perfectly well how each thing is interacting with it with the others, what the whole thing is going to do is just a completely different problem. It's just not, and you need completely different ways of thinking about it.
What do you think about this? I got to ask you a few different attempts at a theory of everything, especially recently. So I've been, for many years, a big fan of cellular automata of complex systems. And obviously, because of that, a fan of Stephen Wolfram's work in that space. But he's recently been talking about a theory of everything through his physics project, essentially. What do you think about this kind of discrete theory of everything, like from simple rules and simple objects on hypergraphs emerges all of our reality, where time and space are emergent. Basically, everything we see around us is emergent.
I have to say, unfortunately, I've kind of pretty much zero sympathy for that. I mean, I don't. I spent a little time looking at it, and I just don't see. It doesn't seem to me to get anywhere, and it really is just really doesn't agree at all with what I'm seeing. Is the kind of unification of math and physics that I'm kind of talking about around certain kinds of very deep ideas about geometry and stuff. This, if you want to believe that your things are really coming out of cellular automata at the most fundamental level, you have to believe that everything that I've seen my whole career and as beautiful, powerful ideas, that's all just kind of a mirage, which just kind of randomly is emerging from these more basic, very, very simple-minded things. And you have to give me some serious evidence for that, and I'm saying nothing.
So the mirage, you don't think there could be a consistency where things like quantum mechanics could emerge from much smaller, discrete, like computational type systems?
Well, I think from the point of view of certain mathematical point of view, quantum mechanics is already mathematically as simple as it gets. It really is a story about really the fundamental objects that you work with when you write down a quantum theory are, in some sense, from one point of view, precisely the fundamental objects at the deepest levels of mathematics you're working with. They're exactly the same. So, and cellular automata are something completely different, which don't fit into these structures. And so, I just don't see why. Anyway, I don't see it as a promising, promising thing to do. And then just looking at it, seeing, does this go anywhere? Does this solve any problem that I didn't? Does this solve any problem of any kind? I just don't see it.
Yeah, to me, cellular automata and these hypergraphs, I'm not sure solving the problem is even a standard to apply here at this moment. To me, the fascinating thing is that the question it asks have no good answers. So there's not good math explaining, forget the physics of it, math explaining the behavior of complex systems.
Yeah.
And that to me is both exciting and paralyzing. Like we're at the very early days of understanding, how complicated and fascinating things emerge from simple rules.
Yeah, I agree. I think that is a truly great problem, and depending where it goes, it may be, it may start to develop some kind of connections to the things that I've kind of found more fruitful and hard to know. It's just that I think a lot of that area, I kind of strongly feel, I guess, not saying too much about it because I don't know too much about it. And again, we're back to this original problem that your time in life is limited. You have to figure out what you're going to spend your time thinking about, and that's something I've just never seen enough to convince me to spend more time thinking about.
Well, also timing. It's not just that our time is limited, but the timing of the kind of things you think about. There's some aspect to cellular automata, these kinds of objects that like are very many years away from having big breakthroughs on. And so it's like you have to pick the problems that are solvable today. In fact, my intuition, again, not perhaps biased, is it feels like the kind of complex systems that cellular automata are, would not be solved by human brains.
Yeah.
It feels like something post-human knows or like significantly enhanced humans, meaning like using computational tools, very powerful computational tools to crack these problems open. that's if our approach to science, our ability to understand science, our ability to understand physics will become more and more computational, or there'll be a whole field that's computational in nature, which currently is not the case. Like currently, computation is the thing that sort of assists us in understanding science the way we've been doing it all along. But if there's a whole new, I mean, that whole from new kind of science, right? It's a little bit dramatic, but this if computers could do science on their own, computational systems, perhaps that's the way they would do the science. They would try to understand the cellular automata, and that feels like we're decades away. So perhaps they'll crack open some interesting facets of this physics problem, but it's very far away. So timing is everything.
That's perfectly possible.
Well, let me ask you that in the space of geometry. I don't know how well you know Eric Weinstein.
Oh, quite well.
What are your thoughts about his geometric unity and the space of ideas that he's playing with on in his proposal for theory of everything?
Well, I think that he fundamentally has, I think, the same problems that everybody has had trying to do this. And they're really versions of the same problem that you try to get unity by putting everything into some bigger structure. So he's has some other ones that are not so conventional that he's trying to work with, but he has the same problem that even if he can get a lot farther in terms of having a really well defined, well understood, clear picture of these things he's working with, they're really kind of large geometrical structures, many dimensions, many kinds, and I just don't see any way he's going to have the same problem the string theorists have. How do you get back down to the structures of the standard model, and how do you so I just anyway it's the same. And there's another interesting example of a similar kind of thing is Garrett Leesy's theory. Again, it's a little bit more specific than Eric's. He's working with this E8, but again, I think all these things founder at the same point that you create this unity, but then you don't actually have a good idea how you're going to get back to the actual to the objects we've seen. How are you going to create these big symmetries? How are you going to break them? And then because we don't see those symmetries in the real world, and
so ultimately there would need to be a simple process for collapsing it to 4 dimensions.
You have to explain. Well, yeah, I forget in his case, but it's not just 4 dimensions. It's also these structures you see in the standard model. There's there's very small dimensional groups of symmetries called U1, SU2, and SU3. And the problem and this has been the problem since the beginning, almost immediately after 1973, about a year later, 2 years later, people started talking about grand unified theories. So you take the U1, the SU2, the SU3.
You want to play a game?
You put them together into this bigger structure called the SU5 or SO10. But then you're stuck with this problem that, wait a minute, why does the world not look, why do I not see these SU5 symmetries in the world? I only see these. And so, and I think, those are the kind of thing that Eric, also Garrett, and lots of people are trying to do. They all kind of founder in that same way that they don't have a good answer to that.
Are there lessons, ideas to be learned from theories like that, from Garrett Leesy's, from Eric's?
I don't know. It depends. I have to confess, I haven't looked that closely at Eric's. I mean, he explained this to me personally a few times. I've looked a bit at his paper, but it's again, we're back to the problem of a limited amount of time in life.
Yeah, I mean, it's an interesting effect, right? Why don't more physicists look at it? I mean, I'm in this position that somehow, I've people write me emails for whatever reason, and I work in the space of AI, and so there's a lot of people. Perhaps AI is even way more accessible than physics in a certain sense. So a lot of people write to me with different theories about what they have for how to create general intelligence. And it's, again, a little bit of an excuse I say to myself, like, well, I only have a limited amount of time, so that's why I'm not investigating it. But I wonder if there's ideas out there that are still powerful, that are still fascinating, and that I'm missing because I'm dismissing them because they're outside of the sort of the usual process of academic research.
Yeah, well, I mean, the same thing pretty much every day in my email. Somebody's got a theory or everything about why all of what physicists are doing. I mean, perhaps the most disturbing thing I should say about my being a critic of string theory is that when you realize who your fans are, that they, every day I hear from somebody who said, "Oh, well, since you don't like string theory, you must of course agree with me that this is the right way to think about it." Oh no, oh no, and most of these are you quickly can see this person doesn't know very much and doesn't know what they're doing. Yeah, but there's a whole continuum to people who are quite serious physicists and mathematicians who are making a fairly serious attempt to try to do something, like Eric and Eric, and then your problem is you do once trying to spend more time looking at it, trying to figure out what they're really doing, but then at some point you just realize, wait a minute, for me to really understand exactly what's going on here would just take time I just don't have.
Yeah, it takes a long time. Which is the nice thing about AI is, unlike the kind of physics we're talking about, if your idea is good, that should quite naturally lead to you being able to build a system that's intelligent. So you don't need to get approval from somebody that's saying you have a good idea here. You can just utilize that idea and engineer a system. Like naturally leads to engineering. With physics here, if you have a perfect theory that explains everything, that still doesn't obviously lead one to scientific experiments that can validate that theory, and two to trinkets you can build and sell
Right.
at a store for $5.
You can't make money off of it.
So that makes it much more challenging. Well, let me also ask you about something that you found especially recently appealing, which is Roger Penrose's twistor theory. What is it? What kind of questions might it allow us to answer? What will the answers look like?
It's only in the last couple of years that I really kind of come to really, I think, to appreciate it and to see how to really, I believe, to see how to really do something with it. And I've gotten very excited about that the last year or two. I mean, one way of saying one idea of twistor theory is that it's a different way of thinking about what space and time are, and about what points in space and time are, but which is very interesting that it only really works in 4 dimensions. So 4 dimensions behaves very specially, unlike other dimensions. And in 4 dimensions, there is a way of thinking about space and time geometry where, as well as just thinking about points in space and time, you can also think about different objects. It's called twistors. And then when you do that, you end up with a really interesting insight that you can formulate a theory. You can formulate take a standard theory that we formulate in terms of points of space and time, and you can reformulate in this twistor language. And in this twistor language, it's the fundamental objects are more kind of are actually spheres in some sense, kind of the light code. So maybe one way to say it, which actually I think is really is quite amazing, is if you ask yourself, what do we know about the world? We have this idea that the world out there is all these different points. Well, that's kind of a derived quantity. What we really know about the world is when we open our eyes, what do you see? You see a sphere, and that what you're looking at is a sphere is where the light rays coming into your eyes. And what Penrose says is that, well, what a point in space-time is that sphere of all the light rays coming in. And And he says, and you should formulate your, instead of thinking about points, you should think about the space of those spheres, if you like, and formulate the degrees of freedom as physics as living on those spheres, living on, so you're kind of living on, your degrees of freedom are living on light, whereas not on points. And it's a very different way of thinking about physics. And he and others working with him developed a beautiful mathematical formulas and a way to go back and forth between our kind of some aspects of our standard way we write these things down and work in the so-called twister space. And they certain things worked out very well, but they ended up, I think, kind of stuck by the 80s or 90s, that they weren't a little bit like string theory, that they by using these ideas about twisters, they could develop them in different directions and find all sorts of other interesting things. But they weren't finding any way of doing that brought them back to kind of new insights into physics. And what's kind of gotten me excited really is what I think I have an idea about that I think does actually work. That it goes more in that direction. And I can go on about that endlessly or tell you a little bit about it. But that's I think that's the one kind of easy to explain insight about twister theory. There's some more technical ones. I think it's also very convincing what it tells you about spinners, for instance, but that's some more technical.
Well, first let's linger on the spheres and the length goes. You're saying twistor theory allows you to make that the fundamental object in which you're operating.
Yeah.
First of all, philosophically, that's weird and beautiful. Maybe because it feels like it moves us so much closer to the way human brains perceive reality. So it's almost like our perception is like the content of our perception is the fundamental object of reality. That's very appealing.
Yeah.
Is it mathematically powerful? Is there something you can say? Can you say a little bit more about what the heck that even means? Because it's much easier to think about mathematically like a point in space-time. Like, what does it mean to be operating on the light cone?
It uses a kind of mathematics that's relative, that what was kind of goes back to the 19th century and mathematicians. It's not anyway. It's a bit of a long story, but one problem is that you have to start. It's crucial that you think in terms of complex numbers and not just real numbers. And this, for most people, that makes it harder to. For mathematicians, that's fine. We love doing that, but for most people, that makes it harder to think about. But I think perhaps the way that there is something you can say very specifically about it, in terms of spinners, which I don't know if you want to. I think at some point you want to talk. So maybe
what are spinners?
Let's start with spinners. I think that if we can introduce that, then I can.
By the way, twister is spelled with an O, and spinner is spelled with an O as well.
Yes. Okay. So,
in case you want to Google it and look it up, there's very nice Wikipedia pages as a starting point. I don't know what is a good starting point for twister theory.
Well, what can I say about Penrose? Penrose is actually a very good writer and also a very good draftsman. He's on drafts. To the extent this is visualizable, he actually has done some very nice drawing. So, in almost any kind of expository thing you can find in him writing is a good place to start. He's a remarkable person. But so the spinners are something that independently came out of mathematics and out of physics. And to say where they came out of physics, what people realized when they started looking at elementary particles like electrons or whatever, that there seemed to be some kind of doubling of the degrees of freedom going on. If you counted what was there in some sense in the way you would expect it, and when you started doing quantum mechanics and started looking at elementary particles, there seemed to be 2 degrees of freedom. They're not 1. And one way of seeing it was that if you put your electron in a strong magnetic field and asked what was the energy of it, instead of it having 1 energy, it would have 2 energies, 2 energy levels. And as you increase magnetic field, the splitting would increase. So physicists kind of realized that, wait a minute, so we thought when we were first started doing quantum mechanics that the way to describe particles was in terms of wave functions, and these wave functions were complex values. Well, if if we actually look at particles, that's not right. They're pairs of complex numbers. They're pairs of complex numbers. So, why? So one of the kind of fundamental, from the physics point of view, the fundamental question is, why are all our kind of fundamental particles described by pairs of complex numbers? It's weird. And then, but if you go, and then you can ask, what happens if you take an electron and rotate it? So how do things move in this pair of complex numbers? Well, now if you go back to mathematics, what had been understood in mathematics some years earlier, not that many years earlier, was that if you ask very, very generally, think about geometry of 3 dimensions, and if you think about things that are happening in 3 dimensions in the standard way, the standard way of doing geometry, everything is about vectors. Right? So if you take any mathematics classes, you probably see vectors at some point. There's triplets of numbers tell you what a direction is or how far you're going in 3-dimensional space. And everything we teach in most standard courses in mathematics is about vectors and things you build out of vectors. So you express everything about geometry in terms of vectors or how they're changing or how you put 2 of them together and get planes and whatever. But what I've been realized is that if you ask very, very generally, what are the things that you can kind of consistently think about rotating? And you ask a technical question: what are the representations of the rotation group? Well, you find that one answer is they're vectors and everything you build out of vectors. But then people find, well, wait a minute, there's also the other things which you can't build out of vectors, but which you can consistently rotate, and they're described by pairs of complex numbers, by 2 complex numbers. And they're the spinors also. And to make and you can think of spinors in some sense as more fundamental than vectors, because you can build vectors out of spinors. You can take 2 spinors and make a vector, but you can't. If you only have vectors, you can't get spinor. So there, in some sense, there's some kind of lower level of geometry beyond what we thought it was, which was kind of spinor geometry. And this is something which, even to this day, when we teach the courses in geometry, we mostly don't talk about this because it's a bit hard to do correctly. If you start with your whole setup is in terms of vectors, describing things in terms of spinors is a whole different ball game. But anyway, it was just this amazing fact that this kind of more fundamental piece of geometry, spinors, and what we were actually seeing, if you look at an electron, are one and the same. So I think it's kind of a mind-blowing thing, but it's very counterintuitive.
What are some weird properties that are counterintuitive?
That there are some things that they do. For instance, if you rotate the spinor around 360 degrees, it doesn't come back to where it becomes minus what it was. So so the way rotations work, there's a kind of a funny sign you have to keep track of in some sense. So they're kind of 2 valued in another weird way. But the fundamental problem is that it's just not. If you're used to visualizing vectors, there's nothing you can do visualizing in terms of vectors that will ever give you a spinor. It just is not going to ever work.
As you were saying that, I was visualizing a vector walking along a Mobius strip, and it ends up being upside down. But you're saying that doesn't really capture it.
So, I mean, what really captures it? The problem is that it's really the simplest way to describe it is in terms of 2 complex numbers. And your problem with 2 complex numbers is that's 4 real numbers. So your spinor kind of lies in a 4-dimensional space. So that makes it hard to visualize. And it's crucial that it's not just 4 dimensions. It's just that it's actually complex numbers. You're really going to use the fact that these are the complex numbers. So it's very hard to visualize. But to get back to what I think is mind-blowing about twistors is that another way of saying this idea about talking about spheres, another way of saying the fundamental idea of twistor theory is, in some sense, the fundamental idea of twistor theory is that a point is a two complex dimensional space, so that it lives inside the space that it lies inside is twistor space. So in the simplest case, twistor space is four-dimensional, and a point in space-time is a two complex dimensional subspace of all the four complex dimensions. And as you move around in space-time, you're just moving, your planes are just moving around. Okay, and that, but then
it's a plane in a four-dimensional space.
It's a plane, complex plane. So it's two complex dimensions and four complex. Okay, but then to me, the mind-blowing thing about this is this then kind of tautologically answers the question: is what is a spinner? Well, a spinner is a point. I mean, the space of spinners at a point is the point. In twistor theory, the points are the complex two planes. And you want me to, and you're asking what a spinner is. Well, a spinner, the space of spinners is that two plane. So it's, just your whole definition of what a point in space-time was just told you what a spinner was. It's the same thing.
Yeah, well, we're trying to project that into a three-dimensional space and trying to intuit, but you can't.
So the intuition becomes very difficult. But if you're not using twistor theory, you have to kind of go through a certain fairly complicated rigmarole to even describe spinners, to describe electrons. Whereas using twistor theory, it's just completely tautological. They're just what you want to describe the electron is fundamentally the way you're describing the point in space that it's just there. So,
do you have a hope? You mentioned that you found it appealing recently. Is it just because of certain aspects of its mathematical beauty, or do you actually have a hope that this might lead to a theory of everything?
Yeah, I certainly do have such a hope, because what I've found, I think the thing which I've done, which I don't think, as far as I can tell, no one had really looked at from this point of view before, has to do with this question of how do you treat time in your quantum theory. And so there's another long story about how we do quantum theories, about how we treat time in quantum theories, which is a long story. But the short version of it is that what people have found when you try and write down a quantum theory, that it's often a good idea to take your time coordinate, whatever you're using your time coordinate, and multiply it by the square root of -1 and make it purely imaginary. And so all these formulas which you have in your standard theory, if you do that to those formulas have some very strange behavior, and they're kind of singular. If you ask even some simple questions, you have to take very delicate singular limits in order to get the correct answer, and you have to take them from the right direction, otherwise it doesn't work. Whereas if you just take time, and if you just put a factor of square root of -1 wherever you see the time coordinate, you end up with much simpler formulas which are much better behaved mathematically. And what I hadn't really appreciated until fairly recently is also how dramatically that changes the whole structure of the theory. You end up with a consistent way of talking about these quantum theories, but it has some very different flavor and very different aspects that I had really appreciated. In a particular way, the way symmetries act on it is not at all what I had originally expected. And so that's the new thing that I think gives you something, is to do this move, which people often think of as just kind of a mathematical trick that you're doing to make some formulas work out nicely, but to take that mathematical trick as really fundamental. And turns out a twistor theory allows you to simultaneously talk about your usual time and the time times the square root of -1. They both fit very nicely into twistor theory, and you end up with some structures which look a lot like the standard model.
Well, let me ask you about some Nobel Prizes.
Okay.
Do you think there will be? There was a bet between Mitchell Cocker and somebody else about
John Horgan.
About. By the way, maybe discover a cool website, longbets.com or .org.
Yeah.
It's cool. It's cool that you can make a bet with people and then check in 20 years later. I really love it. There's a lot of interesting bets on there.
Yeah.
I would love to participate. But it's interesting to see. Time flies.
Yeah.
And you make a bet about what's going to happen in 20 years. You don't realize 20 years just goes like this.
Yeah.
And then you get to face out, and you get to wonder Like, what was that person? What was I thinking? That person 20 years ago is almost like a different person. What was I thinking back then to think that? Is interesting. But so let me ask you this on record. 20 years from now or some number of years from now, do you think there'll be a Nobel Prize given for something directly connected to a first broadly theory of everything, and second, of course, one of the possibilities, one of them, string theory?
Um, String theory is definitely not that things have gone. Yeah.
So if you were given financial advice, you'd say not to bet on.
No, do not. And even I actually suspect if you ask string theorists that question these days, you're going to get few of them saying. I mean, if you'd asked them that question 20 years ago, again when Kaku was making the bed, whatever, I think some of them would have taken you up on it. But and certainly back in 1984, a bunch of them would have said, "Oh, sure, yeah." But now, like, I get the impression that they realize that things are not looking good for that particular idea. Again, it depends what you mean by string theory. Whether maybe the term will evolve to mean something else, which will work out. But I don't think that's not going to likely work out. Whether something else. I mean, I still think it's relatively unlikely that you'll have any really successful theory. And the main problem is just it's become so difficult to do experiments at higher energy that we've really lost this ability to kind of get unexpected input from experiment. And you can, while it's maybe hard to figure out what people's thinking is going to be 20 years from now, looking at high energy colliders and their technology, it's actually pretty easy to make a pretty accurate guess what it's going to look like, except what you're going to be doing 20 years from now. And I think actually, I would actually claim that it's pretty clear what you're going to be 20 years from now, and what it's going to be is you're going to have the LHC. You're going to have a lot more data, an order of magnitude or more data from the LHC, but at the same energy, you're not going to see a higher energy accelerator operating successfully in the next 20 years.
And maybe machine learning or create some data science methodologies that process that data will not reveal any major shifts in our understanding of the underlying physics, you think?
I don't think so. I mean, I think that field, my understanding is that they're starting to make a great use of those techniques, but it seems to look like it will help them solve certain technical problems and be able to do things somewhat better, but not completely change the way they're looking at things.
What do you think about potential quantum computers simulating quantum mechanical systems, and through that sneak up to sort of through simulation, sneak up to a deep understanding of the fundamental physics?
The problem there is that's promising more for this for Phil Anderson's problem. If you want to, there's lots and lots of you start putting together lots and lots of things, and we think we know their pair interactions, but what this thing is going to do, we don't have any good calculational techniques. Quantum computers may very well give you those, and so they may, what we think of as kind of strong coupling behavior, where we have no good way to calculate. Even though we can write down the theory, we don't know how to calculate anything with any accuracy in it. The quantum computers may solve that problem, but the problem is that I don't think that they're going to solve the problem, that they help you with the problem of not having of knowing what the right underlying theory is.
As somebody who likes experimental validation, let me ask you the perhaps ridiculous sounding, but I don't think it's actually a ridiculous question of, do you think we live in a simulation? And do you find that thought experiment at all useful or interesting?
Not really. Not really. I don't. It just doesn't. And anyway, to me, it doesn't actually lead to any kind of anywhere interesting.
Yeah, to me, maybe I'll throw a wrench into your thing. To me, it's super interesting from an engineering perspective. So if you look at virtual reality systems, the actual question is, how much computation and how difficult is it to construct a world that like there are several levels here. One is you won't know the different, our human perception systems, and maybe even the tools of physics won't know the difference between the simulated world and the real world. That's sort of more of a physics question. The most interesting question to me has more to do with why food tastes delicious, which is how difficult and how much computation is required to construct a simulation where you kind of know the simulation at first, but you want to stay there anyway. And over time, you don't even remember.
Yeah. Well, yeah. Anyway, I agree. These are kind of fascinating questions, and they may be very, very relevant to our future as a species. But yeah, they're just very far from anything
So, from a physics perspective, it's not useful to you to think, taking a computational perspective to our universe, think of it as an information processing system, and then think of it as doing computation, and then you think about the resources required to do that kind of computation, all that kind of stuff. You could just look at the basic physics, and who cares what the computer it's running on is.
Yeah, it just, I mean, the kinds of, I'm willing to agree that you can get into interesting kinds of questions going down that road, but they're just so different from anything from what I found interesting that I just have to have it go back to life is too short. And I'm very glad other people are thinking about this, but I just don't see anything I can do with it.
What about space itself? So I have to ask you about aliens. Again, it's something, since you emphasize evidence, do you think there are, how many intelligent alien civilizations are out there?
I have no idea. But as far as I know, unless the government's covering it up or something, we haven't heard from. We don't have any evidence for such things yet. But there seems to be no particular instruction or why there shouldn't be. So,
I mean, do you work on some fundamental questions about the physics of reality? When you look up to the stars, do you think about whether somebody's looking back at us?
you see, well, actually, I originally got interested in physics. I actually started out as a kid interested in astronomy, exactly that, telescope and whatever that. I read a lot of science fiction and thought about that. I find over the years, I find myself kind of less and less interested in that one, just because I don't really know what to do with them. I'm also just kind of at some point kind of stopped reading science fiction that much, kind of feeling that there's just too. But the actual science I was kind of learning about was perfectly kind of weird and fascinating and unusual enough, but better than any of the stuff in Isaac Asimov. So why shouldn't I?
Yeah, and you can mess with the science much more than the distant science fiction. The one that exists in our imagination, or the one that exists out there among the stars. Well, you mentioned science fiction. You've written quite a few book reviews. I'm going to ask you about some books, perhaps, if you don't mind. Is there one or two books that you would recommend to others, and maybe, if you can, what ideas you drew from them? Either negative recommendations or positive.
Well,
do not read this book for sure.
Well, I must say, unfortunately, you can go to my website and you can click on book reviews and you can see I've read a lot of. As you can tell from my views about string theory, I'm not a fan of a lot of the kind of popular books about isn't string theory great, and so I'm not a fan of a lot of things of that kind.
Can I ask you a quick question? Just a small tangent. Are you a fan? Can you explore the pros and cons of, forget string theory, sort of science communication, sort of Cosmos style communication of concepts to people that are outside of physics, outside of mathematics, outside of even the sciences, and helping people to sort of dream and fill them with awe about the full range of mysteries in our universe?
It's a complicated issue. I think, I certainly go back to what inspired me, and maybe to connect it a little bit to the question about books. Certainly some books that I remember reading when I was a kid were about the early history of quantum mechanics, like Heisenberg's books that he wrote about, kind of looking back at telling the story of what happened when he developed quantum mechanics. It's just kind of totally fascinating, romantic, great story, and those were very inspirational to me. And I would think maybe other people might also find them. But
And that's almost like the human story of the development of the ideas.
yeah, the human story, but just also how they these very very weird ideas that didn't seem to make sense, that how they were struggling with them, and how they actually anyway. It's I think it's the period of physics kind of beginning 1905, Planck and Einstein, and ending up with the war when these things get used to make massively destructive weapons. It's just literally amazing.
So many new ideas. Let me, on another tangent on top of a tangent on top of a tangent, ask, if we didn't have Einstein, so how does science progress? Is it the lone geniuses, or is it some kind of weird network of ideas swimming in the air, and just kind of the geniuses pop up to catch them, and others would anyway? Without Einstein, would we have special relativity, general relativity?
I mean, it's an interesting case-to-case basis. I mean, special relativity. I think we would have had. I mean, there are other people. You could even argue that it was already there in some forms, but I think special relativity you would have had without Einstein fairly quickly. General relativity, that was a much harder thing to do, and required much more effort, much more study. I think you would have had sooner or later, but it would have taken quite a bit longer.
Other thing that took a bunch of years to validate scientifically, general relativity.
But even for Einstein, from the point where he had kind of a general idea of what he was trying to do, to the point where he actually had a well-defined theory that you could actually compare to the real world, that was I forget the number, of the order of magnitude 10 years of very serious work. And if he hadn't been around to do that, it would have taken a while before anyone else got around to it. On the other hand, there are things like with quantum mechanics, you have Heisenberg and Schrodinger came up with two, which ultimately equivalent, but two different approaches to it, within months of each other. And so if Heisenberg had been there, he already would have had Schrodinger or whatever. And if neither of them had been there, it would have been somebody else a few months later. So there are times when often it's the combination of the right ideas are in place and the right experimental data is in place to point in the right direction, and it's just waiting for somebody's going to find it. Maybe to go back to your aliens, I guess the one thing I often wonder about aliens is, would they have the same fundamental physics ideas as we have in mathematics? Would they? How much is this really intrinsic to our minds? If you start out with a different kind of mind, when you end up with a different ideas of what fundamental physics is, or what the structure of mathematics is.
So this is why, if I was, I like video games, I would do it as a curious being. So the first experiment I'd like to do is run Earth over many thousands of times and see if our particular, no, you know what? I wouldn't do the full evolution. I would start at Homo sapiens first, and then see the evolution of Homo sapiens millions of times, and see how the ideas of science would evolve. Like, would you get, how would physics evolve? How would math evolve? I would particularly just be curious about the notation they come up with. Every once in a while, I would throw miracles at them to mess with them and stuff. And then I would also like to run Earth from the very beginning to see if evolution will produce different kinds of brains that would then produce different kinds of mathematics and physics. And then finally, I would probably millions of times run the universe over to see what kind of environments and what kind of life would be created to then lead to intelligent life, to then lead to theories of mathematics and physics, and to see the full range. And Darwin kind of mark, okay, it took them, several 100 million years to come up with calculus. I would just keep noting how long it took, get an average, and see which ideas are difficult, which are not, and then conclusively sort of figure out if it's more collective intelligence or singular intelligence that's responsible for shifts and for big phase shifts and breakthroughs in science. Like if I was playing a video game and got a chance to run this whole thing.
But
we're talking about books. Before I
books,
distract
okay, so books, yeah, go back to books. So and then so that's one thing I recommend is the books about from the original people, especially Heisenberg, about how that happened. And there's also a very, very good kind of history of the kind of what happened during this 20th century in physics, and up to the time of the Standard Model in 1973. It's called the Second Creation by Priest, and that's one of the best ones. I know that's. But the one thing that I can say is that that book, I think, I forget when it was, late 80s, 90s. And the problem is that there just hasn't been much that's actually worked out since then. So most of the books that are kind of trying to tell you about all the glorious things that have happened since 1973 they're mostly telling you about how glorious things are, which actually don't really work. And it's really the argument people sometimes make in favor of these books as well. That they're really great because you want to do something that will get kids excited. So they're getting excited about something that's not really quite working. It doesn't really matter. The main thing is get them excited. The other argument is, wait a minute, if you're getting people excited about ideas that are wrong, you're actually kind of discrediting the whole scientific enterprise in a not really good way. So there's problems. So my general feeling about expository stuff is, it's to the extent you can do it kind of honestly and well, that's great. There are a lot of people doing that now, but to the extent that you're just trying to get people excited and enthusiastic by kind of telling them stuff which isn't really true, you really shouldn't be doing that.
You obviously have a much better intuition about physics. I tend to, in the space of AI, for example, you can use certain kinds of language, like calling things intelligent, that could rub people the wrong way. But I never had a problem with that kind of thing. Saying that a program can learn its way without any human supervision, as AlphaZero does to play chess. To me, that may not be intelligence, but it's sure that as heck seems like a few steps down the path towards intelligence. And so, I think that's a very peculiar property of systems that can be engineered. So even if the idea is fuzzy, even if you're not really sure what intelligence is, or if you don't have a deep fundamental understanding or even a model of what intelligence is, if you build a system that sure as heck is impressive and showing some of the signs of what previously thought impossible for a non-intelligent system, then that's impressive and that's inspiring and that's okay to celebrate. In physics, because you're not engineering anything, you're just now swimming in the space indirectly when you do theoretical physics. It could be more dangerous. You could be out too far away from shore.
Yeah. Well, the problem, I think, with physics I think it's actually hard for people even to believe or really understand how that this particular kind of physics has gotten itself into a really unusual and strange and historically unusual state, which is not really. I spent half my life among mathematicians and physicists, and mathematics is kind of doing fine. People are making progress. It has all the usual problems, but also, so you could have a. But I don't know. I've never seen anything at all happening in mathematics like what's happened in the specific area of physics. It's just the kind of sociology of the way this field works, banging up against this hard a problem without anything from experiment to help it. It's led to some really kind of problematic things, and those. So it's one thing to kind of oversimplify or to slightly misrepresent, to try to explain things in a way that's not quite right. But it's another thing to start promoting to people as successes ideas which really completely fail. And so I'm kind of very, very specific. If you start have people, won't name any names, for instance, coming on certain podcasts like yours, telling the world, this is a huge success and this is really wonderful, and it's just not true. And this is really problematic, and it carries a serious danger of once when people realize that this is what's going on, then the loss of credibility of science is a real problem for our society. You don't want people to have an all too good reason to think that what they're being told by kind of some of the best institutions in our country or authorities is not true. Is not true. It's a problem.
That's obviously characteristic of not just physics. It's sociology, and it's I mean, obviously in the space of politics, that's the history of politics. Is you, um, you sell ideas to people even when you don't have any proof that those ideas actually work. You speak as if they have worked, and that seems to be the case throughout history. Um, and just like you said, as human beings running up against a really hard problem. I'm not sure if this is like a particular like trajectory through the progress of physics that we're dealing with now, or is it just the natural progress of science? You run up against a really difficult stage of a field, and different people behave differently to that. Some sell books and sort of tell narratives that are beautiful and so on. They're not necessarily grounded in solutions that have proven themselves. Others kind of put their head down quietly, keep doing the work. Others sort of pivot to different fields. And it's kind of like ants scattering. And then you have fields like machine learning, which is there's a few folks mostly scattered away from machine learning in the 90s, in the winter of AI winter, as they call it. But a few people kept their head down, and now they're called the fathers of deep learning. And they didn't think of it that way. And in fact, if there's another AI winter, they'll just probably keep working on it anyway. Sort of like royal ants to a particular.
Sure, yeah.
So it's interesting, but you're sort of saying that we should be careful overhyping things that have not proven themselves, because people would lose trust in the scientific process.
Yeah.
But unfortunately, there's been other ways in which people have lost trust in the scientific process. That ultimately has to do actually with all the same kind of behaviors you're highlighting, which is not being honest and transparent about the flaws of mistakes of the past.
Yeah, that's always a problem. But this particular field is kind of it's always a strange one. I mean, I think in the sense that there's a lot of public fascination with it, but it seems to speak to kind of our deepest questions about what is this physical reality? Where do we come from? What are these kind of deep issues? And there's this unusual fascination. Mathematics is very different. Nobody's that interested in mathematics. Nobody really kind of expects to learn really great deep things about the world from mathematics that much. They don't ask mathematicians that. So it's a very unusual. It draws this kind of unusual amount of attention, and it really is historically in a really unusual state. It's kind of it's gotten itself way kind of down a blind alley in a way which it's hard to find other historical parallels.
But sort of to push back a little bit, there's power to inspiring people. And if I just empirically look, physicists are really good at combining science and philosophy and communicating it. Like, there's something about physics often that forces you to build a strong intuition about the way reality works, right? And that allows you to think through sort of and communicate about all kinds of questions. Like if you see physicists, it's always fascinating. Take on problems that have nothing to do with their particular discipline. They think in interesting ways and are able to communicate their thinking in interesting ways. And so, in some sense, they have a responsibility not just to do science, but to inspire. And not responsibility, but the opportunity, and thereby, I would say, a little bit of a responsibility.
Yeah, and so but I don't know. Anyway, it's hard to say because different. There's many people doing this kind of thing with different degrees of success and whatever. I guess one thing. But I mean, what's kind of front and center for me is kind of more parochial interest. Is just kind of what damage do you do to the subject itself, ignoring things. misrepresenting, what high school students think about string theory. And that it doesn't matter much, but what the smartest undergraduates or the smartest graduate students in the world think about it, and what paths you're leading them down, and what story you're telling them, and what textbooks you're making them read, and what they're hearing. And so a lot of what's motivated me is more to try to speak to this kind of a specific population of people, to make sure that, look, people, it doesn't matter so much what the what the average person on the street thinks about string theory, but what the best students at Columbia or Harvard or Princeton or whatever who really want to change, work in this field and want to work that way, what they know about it, what they think about it, and that they not be going to the field being misled and believing that a certain story, this is where this is all going, this is what I got to do, it's important to me.
Well, in general, for graduate students, for people who seem to be experts in the field, diversity of ideas is really powerful. And it is getting into this local pocket of ideas that people hold on to for several decades is not good, no matter what the idea. I would say no matter if the idea is right or wrong.
Yeah.
Because there's no such thing as right in the long term. Like, it's right for now until somebody builds on something much bigger on top of it. It might end up being right, but being a tiny subset of a much bigger thing. So there, you always should question sort of the.
Excellent. How'd you find out about it? Okay, doing what? How's your life been since then? Excellent. Good to hear. Well, we're just watching AI podcast. Hope you'd enjoy. Yeah, dog. No, it's about AI. It's Alex Friedman podcast. I agree.
The ways of the past.
Yeah. So how to kind of achieve that kind of diversity of thought within kind of the sociology of how we organize scientific research is, this is one thing that I think is very interesting that Sabina Hassenfelder has very interesting things to say about it. I think also Lee Smolin in his book, which is also about very much in agreement with them, that there's a really kind of important questions about how research in this field is organized, and how people, what can you do to kind of get more diversity of thought, and get people thinking about a wider range of ideas.
At the bottom, I think humility always helps.
but the problem is that it's also a combination of humility to know when you're wrong, but also you have to have a certain very serious lack of humility to believe that you're going to make progress on some of these problems.
I think you have to have like both modes and switch between them when needed. Let me ask you a question you're probably not going to want to answer, because you're focused on the mathematics of things, and mathematics can't answer the why questions, but let me ask you anyway. Do you think there's meaning to this whole thing? What do you think is the meaning of life? Why are we here?
I don't know. Yeah, it did occur to me. One interesting thing about that question is that you don't. Yes, I have this life in mathematics and this life in physics, and I see some of my physicist colleagues, kind of seem to be people are often asking them what's the meaning of life, and they're writing books about the meaning of life and teaching courses about the meaning of life. But then I realized that no one ever asked my mathematician. Nobody ever asked mathematicians.
Yeah, that's funny.
So everybody just kind of seems, okay, well, you people are studying mathematics, whatever you're doing, it's maybe very interesting, but it's clearly not going to tell you anything useful about the meaning of my life. And I'm afraid a lot of my point of view is that if people realize how little difference there was between what the mathematicians are doing and what a lot of these theoretical physicists are doing, they might understand that it's a bit misguided to look for deep insight into the meaning of life from from many theoretical physicists. It's not they're people, and they may have interesting things to say about this. You're right, they know a lot about physical reality and about in some sense about metaphysics, about what is real of this kind. But you're also, in my mind, I think you're also making a bit of a mistake that you're looking to. I'm very, very aware that I've led a very pleasant and fairly privileged existence, and without any challenges of different kinds and a certain kind. And I'm really not in no way the kind of person that a lot of people who are looking for trying to understand in some sense the meaning of life in the sense of the challenges that they're facing in life. I'm really the wrong person for you to be asking about this.
Well, if struggle is somehow a thing that's core to meaning, perhaps mathematicians are just quietly the ones who are most equipped to answer that question. If in fact the creation, or at least experiencing beauty, is is at the core of the meaning of life, because it seems like mathematics is the methodology by which you can most purely explore beautiful things, right?
Yeah.
So in some sense, maybe we should talk to mathematicians more.
Yeah, maybe, but the unfortunately, people do have a somewhat correct perception that what these people are doing every day, whatever, is pretty far removed from anything. Yeah, from what's kind of close to what I do every day and what my typical concerns are. So you may learn something very interesting by talking to mathematicians, but it's probably not going to be. You're probably not going to get what you were hoping.
So when you put the pen and paper down, and you're not thinking about physics, and you're not thinking about mathematics, you just get to breathe in the air and look around you and realize that you're going to die one day. Do you think about that? Your ideas will live on, but you, the human,
not especially much. But certainly, I've been getting older now. 64 years old. You start to realize, well, there's probably less ahead than there was behind, and so that starts to become. Wait a minute, what do I think about that? Maybe I should actually get serious about getting some things done, which I may otherwise not have time to do, which I didn't see. This didn't seem to be a problem when I was younger, but that's the main way in which that thought occurred.
but it doesn't. The Stoics are big on this. Meditating on mortality helps you more intensely appreciate the beauty when you do experience it.
I suppose that's true, but it's not. Yeah, it's not something I spend a lot of time trying. But yeah,
Day to day, you just enjoy the positives of mathematics.
just enjoy. Yeah, our life in general. Life is a perfectly pleasant life, and enjoy it. And often think, wow, things are. I'm really enjoying this. Things are going well.
Yeah, life is pretty amazing. I think you and I are pretty lucky we get to live in this nice little earth.
Yeah.
With a nice little comfortable climate. We get to have this nice little podcast conversation. Thank you so much for spending your valuable time with me today and having this conversation. Thank you.
Good. Thank you.
Thanks for listening to this conversation with Peter White. To support this podcast, please check out our sponsors in the description. And now, let me leave you with some words from Richard Feynman. The first principle is that you must not fool yourself, and you are the easiest person to fool. Thank you for listening. Hope to see you next time.
Don't worry, you got another one coming out. It should be momentarily loading.
The following is a conversation with Jamie Betzel, author specializing in topics of genetic engineering, biotechnology, and geopolitics. In the past 2 years, he has been outspoken about the need to investigate and keep an open mind about the origins of COVID-19. In particular, he has been keeping an extensive, up-to-date collection of circumstantial evidence in support of what is colloquially known as lab leak hypothesis, that COVID-19 leaked in 2019 from the Wuhan Institute of Virology. In part, I wanted to explore the idea in response to the thoughtful criticism in parts of the Francis Collins episode. I will have more and more difficult conversations like this with people from all walks of life, with all kinds of ideas. I promise to do my best to keep an open mind and yet to ask hard questions, while together searching for beautiful and inspiring in the mind of the other person. It's a hard line to walk gracefully, especially for someone like me, who's a bit of an awkward introvert with barely the grasp of the English language, or any language, except maybe Python and C++. But I hope you stick around, be patient and empathetic, and maybe learn something new together with me. This is a Let's Read It podcast. To support it, please check out our sponsors in the description. And now, here's my conversation with Jamie Metzen. What is the probability in your mind that COVID-19 leaked from a lab? In your write-up, I believe you said 85%. I know it's just a percentage, you can't really be exact with these kinds of things, but it gives us a sense where your mind is, where your intuition is. So, as it stands today, what would you say to that probability?
I would stand by what I've been saying since really the middle of last year. More likely than not, in my opinion, that the pandemic stems from an accidental lab incident. Is it 90%? Is it 65%? And that's kind of arbitrary. But when I stack up all of the available evidence, and all of it on both sides is circumstantial, it weighs very significantly toward a lab incident.
So, before we dive into the specifics at a high level, what types of evidence, what intuition, what ideas are leading you to have that kind of estimate? Is it possible to kind of condense, when you look at the wall of evidence before you, where's your source, the strongest source of the information?
Yeah. And I would have to say it's just logic and deductive reasoning. So before I make the case for why I think it's most likely a lab incident origin, let's just say why it could be, and still could be, what we call natural origin. All of this is the natural origin in the sense that it's a bad virus backbone, horseshoe bad virus backbone.
Okay, I'm going to keep pausing you, define stuff. So maybe it's useful to say, what do we mean by lab leak? What do we mean by natural origin? What do we mean by virus backbone?
Okay, great question. So viruses come from somewhere. Viruses have been around for 3.5 billion years, and they've been around for such a long time because they are adaptive, and they're growing, and they're always changing, and they're morphing. And that's why viruses have been very successful, and we are victims. Sometimes we're beneficiaries. We have viral DNA has morphed into our genomes, but now, and certainly in the case of COVID-19, we are victims of the success of viruses. And so when we talk about a backbone, so the SARS-CoV-2 virus has a history, and these viruses don't come out of whole cloth. There are viruses that morph, and so we know that at some period, maybe 20 years ago or whatever, the virus that is SARS-CoV-2 existed in horseshoe bats. It was a horseshoe bat virus, and it evolved somewhere. And there are some people who say there's no evidence of this, but it's a plausible theory based on how things have happened in the past. Maybe that virus jumped from the horseshoe bat through some intermediate species. So it's like, let's say there's a bat, and then it infects some other animal. Let's say it's a pig or a raccoon dog or a civet cat. They're all pangolin. They're all sorts of animals that have been considered. And then that virus adapts into that new host, and it changes and grows. And then, according to the quote-unquote natural origins hypothesis, it jumps from that animal into humans. And so what you could imagine that some of the people who are making the case, all of the people actually were making the case for a natural origin of the virus. What they're saying is it went from bat to some intermediate species, and then from that intermediate species, most likely, there's some people who say it went directly bat to human, but to some intermediate species, and then humans interacted with that species, and then it jumped from that, whatever it is, to humans. And that's a very plausible theory. It's just that there's no evidence for it.
And the nature of the interaction is, do most people kind of suggest, is that the like wet markets. So the interaction of the humans with the animal is in the form of, it's either a live animal that's being sold to be eaten, or a recently live animal but newly dead animal being sold to.
That's certainly one very possible possibility, if that's a word. But the people who believe in the wet market origin, that's what they're saying. So they had one of these animals, they were cutting it up, let's say, in a market, maybe some of the blood got into somebody's, maybe had a cut on their hand, or maybe it was aerosolized, and so somebody breathed it, and then that virus found this new host, and that was the human host. But you could also have that happen in, let's say, a farm. So it's happened in the past that, let's say, that there are farms, and because of human encroachment into wild spaces, we're pushing our farms and our animal farms further and further into what used to be the just natural habitats. And so it's happened in the past, for example, that there were bats roosting over pig pens, and the bat droppings went into the pig pens. The viruses in those droppings infected the pigs, and then the pigs infected the humans. And that's why it's a plausible theory. It's just that there's basically no evidence for it. If it was the case that SARS-CoV-2 comes from this type of interaction, as in most of the at least recent past outbreaks, we'd see evidence of that. Viruses are messy. They're constantly undergoing Darwinian evolution, and they're changing. And it's not that they're just ready for prime time, ready to infect humans on day one. Normally, you can trace the viral evolution prior to the time when it infects humans. But for SARS-CoV-2, it just showed up on the scene, ready to infect humans. And there's no history that anybody has found so far of that kind of viral evolution. The first SARS, you could track it, right? The genome sequencing, that it was experimented. And SARS-CoV-2 was very, very stable, and meaning it had already adapted to humans by the time it interacted with us.
Fully adapted. So with SARS, there's a rapid evolution when it first kind of hooks onto a human.
Yeah, because it's trying. Like a virus, its goal is to survive and replicate. Yeah, no, it's true. It's like, oh, we're going to try this. Oh, that didn't work. We'll try it exactly like a startup. And so we don't see that. And so there are some people who say, right, well, one hypothesis is you have a totally isolated group of humans, maybe in southern China, which is more than 1,000 miles away from maybe they're doing their animal farming right next to these areas where there are these horseshoe bats, and maybe in this totally isolated place that no one's ever heard of, they're not connected to any other place, one person gets infected. And it doesn't spread to anybody else because they're so isolated. They're like, I can't even imagine that this is the case. Then somebody gets in a car and drives all night, more than 1,000 miles through crappy roads to get to Wuhan. Doesn't stop for anything, doesn't infect anybody on the way. No one else in that person's village infects anyone. And then that person goes straight to the Huanan seafood market, according to this, in my mind, not very credible theory, and then unloads his stuff, and everybody gets infected, and they're only delivering those animals to the Wuhan market, which doesn't even sell very many of these kinds of animals that are likely intermediate species, and not to anywhere else. So it's a little bit of a straw man. But on top of that, the Chinese have sequenced more than 80,000 animal samples, and there's no evidence of this type of viral evolution that we would otherwise expect.
Let's try to, at this moment, steel man the argument for the natural origin of the virus. Just to clarify, so Wuhan is actually, despite what it might sound like to people, is a pretty big city. Yeah. There's a lot of people that live in it.
11 billion.
So not only is there, Wuhan Institute of Virology, there's other centers that work on virus.
Yes.
But there's also a giant number of markets, and everything we're talking about here is pretty close together. So when I kind of look at the geography of this, I think when you zoom out, but zoom in, there's just a lot of interesting dynamics that could be happening and where the cases are popping up and what's being reported, all that kind of stuff. So I think the people that argue for the natural origin, there's a few recent papers that come out arguing this. It's kind of fascinating to watch this whole thing. But I think what they're arguing is that there's this Hunan market, that's one of the major markets, the wet markets in Wuhan, that there's a bunch of cases that were reported from there. So if I look at, for example, the Michael Warby perspective, the hero of science, he argues, he wrote this a few days ago, the predominance of early COVID cases linked to the Hunan market, and this can't be dismissed as ascertainment bias, which I think is what people argue, that you're just kind of focusing on this region because a lot of cases came, but there could be a huge number of other cases. So people who argue against this say that this is a later stage already. He says no. He says this is the epicenter, and this is a clear evidence that circumstantial evidence, but evidence nevertheless that this is where the jump happened to humans, the big explosion. Maybe not case zero. I don't know if he argues that, but the early cases. So, what do you make of this whole idea? You steelman it, or
So
about the
and my goal here isn't to attack people on the other side, and if my feeling is if there is evidence that's presented that should change my view, I hope that I'll be open-minded enough to change my view. And certainly Michael Warby is a thoughtful person, a respected scientist, and I think this work is contributive work, but I just don't think that it's as significant as has been reported in the press. And so what his argument is that there's an early cluster in December of 2019 around the Huanan seafood market. And even though he himself argues the original breakthrough case, the original case, the index case where the first person infected happened in October or November, so not in December. His argument is, well, what are the odds that you would have this cluster of cases in the Huanan seafood market, and if the origin happened someplace else, wouldn't you expect other clusters? And it's not an entirely implausible argument, but there are reasons why I think this is not nearly as determinative as has been reported, and I certainly had a lot of, I and others have tweeted a lot about this. And that is first, the people who were infected in this cluster, it's not the earliest known virus. The SARS-CoV-2, it began mutating. So it's not the original SARS-CoV-2 there. So it had to have happened someplace else. Two, the people who infected in the market weren't infected in the part of the market where they had these kinds of animals that are considered to be candidates as an intermediary species. And third, there was a bias, actually I'll flip this. Third, there was a bias in the early assessment in China of what they were looking for. They were asked, did you have exposure to the market? Because I think in the early days when people were figuring things out, that was one of the questions that was asked. And fourth, and probably most significantly, we have so little information about those early cases in China, and that's really unfortunate. I know we'll talk about this later because the Chinese government is preventing access to all of that information, which they have, which could easily help us get to the bottom, at least know more about how this pandemic started. And so it's like grasping at straws in the dark with gloves.
That's right. But to steelman the argument, we have this evidence from this market, and yes, the Chinese government has turned off the lights, essentially, so we have very little data to work with, but this is the data we have. So who's to say that this data doesn't represent a much bigger data set that a lot of people got affected this market, with even at the parts, or especially at the parts where the infected meat was being sold.
So that could be true, and it probably is true. The question is this the source? Is this the place where this began? Or was this just a place where it was amplified? And I certainly think that it's extremely likely that the Guanan seafood market was a point of amplification. And it's just answering a different question.
Basically, what you're saying is it's very difficult to use the market as evidence for anything because it's probably not even the starting point. So it's just a good place for it to continue spreading.
That's certainly my view. What Michael Warby's argument is that, well, what are the odds of that we're seeing this amplification in the market? And if let's think of it this way, if we had all of the information, if the Chinese government had blocked access to all of this, because there's blood bank information, all sorts of information, and based on a full and complete understanding, we came to believe that all of the early cases were at this market. I think that would be a stronger argument than what this is so far. But everything leads to the fact that why is it that the Chinese government, which was frankly after a slow start, the gold standard of doing viral tracking for SARS-1, why have they apparently done so little and shared so little? I think it begs a lot of questions.
Okay, so let's then talk about the Chinese government. There's several governments, right? So one is the local government of Wuhan. And not just the Chinese government, let's talk about government. No, let's talk about human nature. Let's just keep zooming out.
Yeah.
Let's talk about planet Earth.
Yeah.
No. So there's the Wuhan local government, there's the Chinese government led by Xi Jinping, and there's governments in general. I'm trying to empathize. So my father was involved with Chernobyl. I'm trying to put myself into the mind of local officials, of people who are like, oh shit, there's a potential catastrophic event happening here, and it's my ass because there's incompetence all over the place. Yeah, human nature is such that there's incompetence all over the place, and you're always trying to cover it up. And so given that context, I want to lay out all the possible incompetence, all the possible malevolence, all the possible geopolitical tensions here. All right, where in your sense did the cover-up start? So there's this suspicious fact, it seems like, that the Wuhan Institute of Virology had a public database of thousands of sampled bad coronavirus sequences, and that went offline in September of 2019. Well, what's that about?
So let me talk about that specific, and then I'll also follow your path of zooming out. And it's a really important.
Is that a good starting point?
It's a great starting point. Yeah. So, but there's a bigger story. But let me talk about that. So the Wuhan Institute of Virology, and we can go into the whole history of the Wuhan Institute of Virology either now or later, because I think it's very relevant to the story. But let's focus for now on this database. They had a database of 22,000 viral samples and sequence information about viruses that they had collected. Some of which, the collection of some of which was supported through funding from the NIH. Not a huge NIH through Health Alliance. It's a relatively small amount, $600,000, but not nothing. The goal of this database was so that we could understand viral evolution, so that exactly for this kind of moment where we had an unknown virus, we could say, well, is this like anything that we've seen before? And that would help us both understand what we're facing and be better able to respond. So this was a password-protected public access database. In 2019, it was in September 2019, it became inaccessible. And then a few months later, the entire database disappeared. The Chinese have said because there were all kinds of computer attacks on this database. But why would that happen in September 2019 before the pandemic, at least as far as we know?
So just to clarify,
Yes.
it went down to September 2019, just so we get the year straight.
Yeah.
January 2020 is when the virus really started getting the press. So we're talking about December 2019. A lot of early infections happened. September 2019 is when this database goes down. Just to clarify, because you said it quickly, the Chinese government said that their database was getting hacked.
Well,
Therefore,
Xu Zhengli, the director of this part of the Wuhan Institute of Virology, said that.
oh,
She
really?
said-
She was the one that said.
She was the one who said that.
Oh
Yeah.
boy, I did not even know that part.
Yeah.
Okay. Well, she's an interesting character. We'll talk about her.
Yeah.
So the excuse is that getting cyber attacked allows them to take it down without any further explanation, which seems very suspicious. And then this virus starts to emerge in October, November, December. There's a lot of argument about that, but after.
Sorry to interrupt, because some people are saying that the first outbreak could have happened as early as September. I think it's more likely it's October, November. But for the people who are saying that the first outbreak, the first incident of a known outbreak, at least to somebody, happened in September, they make the argument, well, what if that also happened in mid-September of 2019? I'm not prepared to go there, but there are some people who think that.
But I think, again, if I were to put myself in the mind of officials, whether it's officials within the Wuhan Institute of Virology or Wuhan local officials, I think if I notice some major problem, like somebody got sick, some sign of, oh shit, we screwed up, that's when you kind of do the slow, there's like a Homer Simpson meme where you slowly start backing out, and I would probably start hiding stuff.
Yeah.
And then coming up with really shady excuses. It's like you're in a relationship and your girlfriend wants to see your phone, and you're like, I'm sorry, I'm just getting attacked by the Russians now. The cybersecurity, I can't.
Yeah, I wish I could.
I wish I could. It's just unsafe right now.
So would it be okay if I give you my kind of macro view of the whole information space and why I believe this has been so contentious? It's so here's if I had to give my best guess, and I underline the word guess, of what happened, and your family background with Chernobyl, I think is highly relevant here. So after the first SARS, there was a recognition that we needed to distribute knowledge about virology and epidemiology around the world. The people in China and Africa and Southeast Asia, they were the frontline workers, and they needed to be doing a lot of the viral monitoring and assessment so that we could have an early alarm system. And that was why there was a lot of investment in all of those places in building capacity and training people and helping to build institutional capacity. And the Chinese government, they recognized that they needed to ramp things up. And then the World Health Organization, the World Health Assembly, they had their international health regulations that were designed to create a stronger infrastructure. So that was the goal. There were a lot of investments, and I know we'll talk later about the Wuhan Institute of Virology, and I won't go into that right now. So there was all of this distributed capacity. And so in the early days, there's a breakout in Wuhan. We don't know, is it September, October, November, maybe in December is when the local authorities start to recognize that something's happening. But at some point in late 2019, local officials in Wuhan understand that something is happening. And exactly like in Chernobyl, these guys exist within a hierarchical system. And they are going to be rewarded if good things happen, and they're going to be in big trouble if bad things happen under their watch. So their initial instinct is to squash it. And my guess is they think, well, if we squash this information, we can most likely beat back this outbreak, because lots of outbreaks happen all the time, including of SARS-1, where there was multiple lab incidents out of the lab in Beijing. And so they start their cover-up on day one. They start screening social media. They send nasty letters to different doctors and others who are starting to speak up. But then it becomes clear that there's a bigger issue. And then the national government of China, again, this is just a hypothesis, the national government gets involved. They say, all right, this is getting much bigger. They go in and they realize that we have a big problem on our hands. They relatively quickly know that it's spreading human to human. And so the right thing for them to do then is what the South African government is doing now, is to say, we have this outbreak, we don't know everything, but we know it's serious, we need help. But that's not the instinct of people in most governments, and certainly not in authoritarian governments like China. And so the national government, they have a choice at that point. They can do option one, which is what we would here call the right thing, which is total transparency. They criticize the local officials for having this cover up, and they say, now we're going to be totally transparent. But what does that do in a system like the former Soviet Union, like China now? Is local officials say, wait a second, I thought my job was to cover everything up, to support this alternative reality that authoritarian systems need in order to survive. Well, now I'm going to be held accountable for if I'm not totally transparent, like your whole system would collapse. So the national government, they have that choice, and their only choice, according to the logic of their system, is to be all in on a cover-up. And that's why they blocked the World Health Organization from sending its team to Wuhan for over 3 weeks. They overtly lie to the World Health Organization about human-to-human transmission, and then they begin their cover-up. So they begin very, very quickly destroying samples, hiding records. They start imprisoning people for asking basic questions. Soon after, they establish a gag order preventing Chinese scientists from writing or saying anything about pandemic origins without prior government approval. And what that does means that there isn't a lot of data, not nearly enough data, coming out of China. And so lots of responsible scientists outside of China who are data-driven say, well, I don't have enough information to draw conclusions. And then into that vacuum step a relatively small number of largely virologists, but also others, respected scientists. And I know we'll talk about the infamous Peter Daszak, who say, well, without any real foundation in the evidence, they say, we know pretty much this comes from nature. And anyone who's raising the possibility of a lab incident origin is a conspiracy. So that message starts to percolate. And then in the United States, we have Donald Trump. And he's starting to get criticized for America's failure to prepare for and respond adequately to the outbreak. And so he starts saying, well, I know, first after praising Xi Jinping, he starts saying, well, I know that China did it and the WHO did it. He's kind of pointing fingers at everybody but himself. And then we have a media here that had shifted from the traditional model of he said, she said journalism. So-and-so said X and so-and-so said Y, and then we'll present both of those views. With Donald Trump, he would make outlandish starting positions. So he would say, Lex is an expert. And then in the early days, he would say, Lex is an Asperger. Lex's friend says he's not an expert. We have a 4-day debate. Is he or isn't he? And then at day 4, someone would say, why are we having this debate at all? Because the original point is baseless. And so the media have just got in the habit. Here's what Trump said, and here's why it's wrong.
It's very complicated to figure out what is the role of a politician, what is the role of a leader in this kind of game of politics. But certainly, when there's a tragedy, when there's a catastrophic event, what it takes to be a leader is to see clearly through the fog and to make big, bold decisions and to speak to the truth of things. And even if it's unpopular truth, to listen to the people, to listen to all sides, to the opinions, to the controversial ideas, and to see past all the bullshit, all the political bullshit, and just speak to the people, speak to the world, and make bold, big decisions. That's probably what was needed in terms of leadership. And I'm not so willing to criticize whether it's Joe Biden or Donald Trump on this. I think most people cannot be great leaders, but that's why when great leaders step up, we write books about them.
And I agree. And even though I think of myself as a progressive person, I certainly was a critic of a lot of what President Trump did. But on this particular case, even though he may have said it in an uncouth way, Donald Trump was actually, in my view, right. I mean, when he said, hey, let's look at this lab, and he said, I have evidence, I can't tell you, I don't think he even had the evidence. But his intuition that this probably comes from a lab, in my view, was a correct intuition. And certainly I started speaking up about pandemic origins early in 2019. And my friends, my Democratic friends, were brutal with me, saying, what are you doing? You're supporting Trump in an election year. And I said, just because Donald Trump is saying something doesn't mean that I need to oppose it. If Donald Trump says something that I think is correct, well, I want to say it's correct, just as if he says something that I don't like, I'm going to speak up about that.
Good. You walked the fire. So that's you laid out this, and I think in many ways it's a human story. It's a story of politics. It's a story of human nature. But let's talk about the story of the virus, and let's talk about the Wuhan Institute of Virology. So maybe this is a good time to try to talk about its history, about its origins, about what kind of stuff it works on, about biosafety levels, about that woman.
Yeah, Zheng yes.
So what is the Wuhan Institute of Virology? Where did it start?
Yeah, so it's a great question. So after SARS-1, which was in the early 2000s, 2003, 2004, there was this effort to enhance, as I mentioned before, global capacity, including in China. So the Wuhan Institute of Virology had been around for decades before then. But there was an agreement between the French and the Chinese governments to build the largest BSL-4 lab, so biosafety level 4. So in these what are called high containment labs, there's level 4, which is the highest level, and people have seen that on TV and elsewhere, where you have the people in the different suits and all of these protections. And then there's level 3, which is still very serious, but not as much as level 4. And then level 2 is just kind of goggles and some gloves and maybe a face mask, much less. So the French and the Chinese governments agreed that France would help build the first and still the largest BSL-4 plus some mobile BSL-3 labs. And they were going to do it in Wuhan. And Wuhan is kind of like China's Chicago. And I had actually been, it's a different story, I've been in Wuhan relatively not that long before the pandemic broke out, and that was why I knew that Wuhan it's not some backwater where there are a bunch of yokels eating bats for dinner every night. This is a really sophisticated, wealthy, highly educated and cultured city. And so I knew that it wasn't like that. Even the one on seafood market wasn't like some of these seafood markets that they have in southern China or Cambodia, where I lived for 2 years. I mean, it was a totally different thing.
I'm going to talk to you about some of the food, including Wuhan market, just some of the wild food going on here, because you've traveled that part of the world.
Yeah.
But let's not get there.
Yeah.
Let's not get distracted.
Good. As I was telling you, Lex, before, and this is maybe an advertisement, is having now listened to the number of your podcasts when I'm doing long ultra training runs or driving into the mountains. Like because in the beginning you have to talk about whatever it is at the top. The really good stuff happens later.
So friends, you should listen to the end.
I have to say, as I was telling you before, like when I heard your long podcast with Jaron Lanier and he talked about his mother at the very end, I mean, it was just beautiful stuff. So I don't know whether I can match beautiful stuff, but I'm gonna do my best.
You're gonna have to find out.
Exactly. Stay tuned. So France had this agreement that they were going to help design and help build this BSL-4 lab in Wuhan. And it was going to be with French standards, and there were going to be 50 French experts who were going to work there and supervise the work that happened even after the Wuhan Institute of Virology in the new location started operating. But then when they started building it, the French contractors, the French overseers, were increasingly appalled that they had less and less control, that the Chinese contractors were swapping out new things. It wasn't built up to French standards. So much that at the end, when it was finally built, the person who was the vice chairman of the project and a leading French industrialist named Mariot refused to sign off. And he said, we can't support, we have no idea what this is, whether it's safe or not. And when this lab opened, remember we were supposed to have 50 French experts, it had one French expert. So the French were really disgusted. And actually, when the Wuhan Institute of Virology in its new location opened in 2018, two things happened. One, French intelligence privately approached U.S. intelligence saying, we have a lot of concerns about the Wuhan Institute of Virology, about its safety, and we don't even know who's operating there. Is it being used as a dual-use facility? And also in 2018, the U.S. Embassy in Beijing sent some people down to Wuhan to go and look at this laboratory. And they wrote a scathing cable that Josh Rogan from the Washington Post later got his hands on, saying, this is really unsafe. They're doing work on dangerous bat coronaviruses in conditions where a leak is possible. So then you mentioned Shujing Li, and I'll connect that to these virologists who I was talking about. So there's a very credible thesis that because these pathogenic outbreaks happen in other parts of the world, having partnerships with experts in those parts of the world must be a foundation of our efforts. We can't just bring everything home because we know that viruses don't care about borders and boundaries, and so if something happens there, it's going to come here. So very correctly, we have all kinds of partnerships with experts in these labs, and Shujing Li was one of those partners, and her closest relationship was with Peter Daszak, who's a British, I think now American, but the president of a thing called EcoHealth Alliance, which was getting money from NIH. And basically, EcoHealth Alliance was a pass-through organization, and over the years, it was only about $600,000, so almost all of her funding came from the Chinese government, but there's a little bit that came from the United States. And so she became their kind of leading expert and the point of contact between the Wuhan Institute of Virology and certainly Peter Daszak, but also with others. And that was why in the earliest days of the outbreak, I did mention that there were these virologists who had this fake certainty that they knew it came from nature and it didn't come from a lab, and they called people like me conspiracy theorists just for raising that possibility. But when Peter Daszak was organizing that effort in February of 2020, what he said is, we need to rally behind our Chinese colleagues. And that the basic idea was these international collaborations are under threat. And I think it was because of that, because Peter Daszak's basically his major contribution as a scientist was just tacking his name on work that Shujing Li had largely done. He was defending a lot, certainly for himself and his organization.
So do you think EcoHealth Alliance and Peter is less about money and it's more about kind of almost like legacy because you're so attached to this work? It's just not a human link.
So I think so. I mean, I've been criticized for being I'm certainly a big critic of Peter Daszak, but I've been criticized by some for being too lenient. I mean, it's so easy to say, oh, somebody, they're like an evil ogre and just trying to do evil and cackling in their closet or whatever. I think for most of us, even those of us who do terrible, horrible things, the story that we tell ourselves, and we really believe, is that we're doing the thing that we most believe in. I mean, I did my PhD dissertation on the Khmer Rouge in Cambodia. They genuinely saw themselves as idealists. They thought, well, we need to make radical change to build a better future. And what they described as what they felt was radical change was a monstrous atrocity.
So the criticism here of Peter's is that he was part of an organization that was kind of funding an effort that was an unsafe implementation of a biosafety level 4 laboratory.
Well, a few things. So what he thought he was doing and what he thought he was doing is itself highly controversial, because there's one there that in 2011 there were, I know you've talked about this with other guests, but in 2011 there were the first published papers on this now infamous gain of function research. And basically what they did, both in different labs, certainly in the United States, in Wisconsin, and in the Netherlands, was they had a bird flu virus that was very dangerous, but not massively transmissive. And they had a gain of function process through what's called serial passage, which means basically passing a device like natural selection, but forcing natural selection by just passing the virus through different cell cultures and then selecting for what it is that you want. So relatively easily, they took this deadly but not massively transmissive virus and turned it into, in a lab, a deadly and transmissive virus. And that showed that this is really dangerous. And so at that point, there was a huge controversy. There were some people, like Richard Ebright and Mark Lipsitch at Harvard, who were saying that this is really dangerous. We're in the idea that we need to create monsters to study monsters. I think maybe even you have said that in the past. It doesn't make sense because there's an unlimited number of monsters. And so what are we going to do? Create an unlimited number of monsters. And if we do that, eventually the monsters are going to get out. Then there was the Peter Daszak camp, and he got a lot of funding, particularly from the United States. Said, well, and certainly Collins and Fauci were supportive of this. And they thought, well, there's a safe way to go out into the world to collect the world's most dangerous viruses and to poke and prod them to figure out how they might mutate, how they might become more dangerous, with the goal of predicting future pandemics, and that certainly never happened, with the goal of creating vaccines and treatments, and that largely never happened. That was, so Peter Daszak kind of epitomized that second approach. And as you've talked about in the past, in 2014, there was a funding moratorium in the United States, and in 2017, that was lifted. It didn't affect the funding that went to the EcoHealth Alliance. So when this happened in the beginning, and again, coming back to Peter's motivations, I don't think, here's the best case scenario for Peter. I'm going to give you what I imagine he was thinking, and then I'll tell you what I actually think. So I think here's what he's thinking. This is most likely a natural origin outbreak. Just like SARS-1, and again, Peter's hypothetical mind, just like SARS-1, this is most likely a natural outbreak. We need to have an international coalition in order to fight it. If we allow these political attacks to undermine our Chinese counterparts and the trust in these relationships that we've built over many years, we're really screwed because they have the most local knowledge of these outbreaks. And and this guy gets a lot more complicated, even though there are basic questions that anybody would ask, and that Xu Li herself did ask about the origins of this pandemic, even though Peter Daszak, and I'll describe this in a moment, had secret information that we didn't have, that in my mind massively increases the possibility of a lab incident origin. I, Peter Daszak, would like to guide the public conversation in the direction where I think it should go, and in support of the kind of international collaboration that I think is necessary.
That's a strong positive description, because it's true. There's a lot of political BS and a lot of kind of just bickering and lies, as we've talked about. And so it's very convenient to say, you know what, let's just ignore all of these quote unquote lies and the favorite word misinformation. And then, because the way out from this serious pandemic is for us to work together. So let's strengthen our partnerships, and everything else is just like noise.
Yeah, so let's, and so then now I want to do my personal indictment of Peter Daszak, because that's my view, but I want it to fairly,
Nice.
because I think that we all tell ourselves stories, and also when you're a science communicator, you can't, in your public communications, give every doubt that you have or every nuance. You kind of have to summarize things. And so I think that he was, again, in this benign interpretation, trying to summarize it the way that he thought the conversation should go. Here's my indictment of Peter Daszak. And I feel like Brutus here, but I've not come here to praise Peter Daszak, because while Peter Daszak was doing all of this, making all of these statements about, well, we pretty much know it's a natural origin, then there was a very 2020 Lancet letter where it turns out, and we only knew this later, that he was highly manipulative. So he was recruiting all of these people. He drafted the infamous letter calling people like me conspiracy theorists. He then wrote to people like Ralph Barrick and Linfa Wang, who are also very high-profile virologists, saying, well, let's not put our names on it so it doesn't look like we're doing it, even though they were doing it. And he didn't disclose a lot of information that they had.
It was a strategic move. So just in case people are not familiar, February 2020 Lancet letter was TLDR is the lab leak hypothesis is a conspiracy theory.
Essentially, yes.
So, so like with the authority of science, not saying like it's highly likely, saying it's obvious, it's natural origin. Everybody else is just everything else is just misinformation. And look, there's a bunch of really smart people that sign this, therefore it's true.
Yeah. Not only that, so there were the people, 27 people signed that letter, and then after President Trump cut funding to Eco Health Alliance, then he organized 77 Nobel laureates to have a public letter criticizing that. What Peter knew then, that we didn't fully know, is that in March of 2018, Eco Health Alliance, in partnership with the Wuhan Institute of Virology and others, had applied for a $14 million grant to DARPA, which is kind of like the VC side of the venture capital side of the Defense Department. They're kind of where they do kind of big ideas.
By the way, it's a tiny tangent. I've gotten a lot of funding from DARPA. They fund a lot of excellent robotics research.
And DARPA is incredible. And among the things that they applied for is that we, meaning Wuhan Institute of Virology, is going to go and it's going to collect the most dangerous bat coronaviruses in southern China. And then we, as this group, are going to genetically engineer these viruses to insert a furin cleavage site. So I think when everyone's now seen the image of the SARS-CoV-2 virus, it has these little spike proteins, these little things that stick out, which is why they call it a coronavirus. Within that spike protein are these furin cleavage sites, which basically help with the virus getting access into our cells. They're going to genetically engineer these furin cleavage sites into these bat coronaviruses, the cervicoviruses. And so then, a year and a half later, what do we see? We see a bat coronavirus with a furin cleavage site unlike anything that we've ever seen before in that category of SARS-like coronaviruses. Yes, I mean, the DARPA very correctly didn't support that application.
Well, let's actually let's pause on that. So for a lot of people, that's like the smoking gun.
Yeah.
Okay, let's talk about this 2018 proposal to DARPA. So I guess who's drafted the proposal? Is it EcoHealth? But the proposal is to do research. EcoHealth is technically a U.S. funded organization
primarily.
and then the idea was to do work at the Institute of Virology
So it was
with EcoHealth.
so EcoHealth, basically the Wuhan Institute of Virology was going to go and they were going to collect these viruses and store them at Wuhan Institute of Virology.
But they're also going to do the actual data.
It's a really important point. According to their proposal, the actual work was going to be done at the lab of Ralph Barrick at the University of North Carolina, who's probably the world's leading expert on coronaviruses. And so we know that DARPA didn't fund that work. We know, I think, quite well that Ralph Barrick's lab, in part because it was not funded by DARPA, they didn't do that specific work. What we don't know is, well, what work was done at the Wuhan Institute of Virology, because WIV was part of this proposal. They had access to all of the plans. They had their own capacity, and they had already done a lot of work in genetically altering this exact category of viruses. They had created chimeric mixed viruses. They had mastered pretty much all of the steps in order to achieve this thing that they applied for funding with EcoHealth to do. And so the question is, did Wuhan Institute of Virology go through with that research anyway? And in my mind, that's a very, very, very real possibility. It would certainly explain why they're giving no information. And as you know, I've been a member of the World Health Organization Expert Advisory Committee on Human Genome Editing, which Dr. Tedros created in the aftermath of the announcement of the world's first CRISPR babies. And it was just basically the exact same story. So He Jiankui, Chinese scientist, he was not a first-tier scientist, but a perfectly adequate second-tier scientist, came to the United States, learned all of these capacities, went back to China and said, well, there's a much more permissive environment. I'm going to be a world leader. I'm going to establish both myself and China. So in every scientific field, we're seeing this same thing where you kind of learn a model and then you do it in China. So is it possible that the Wuhan Institute of Virology, with this exact game plan, was doing it anyway? Possible? We have no clue what work was being done at the Wuhan Institute of Virology. It seems extremely likely that at the Wuhan Institute of Virology, this is certainly the U.S. government position, there was the work that was being done in Dr. She's lab, but that wasn't the whole WIV. We know, at least according to the United States government, that there was the Chinese military, the PLA, was doing work there. Were they doing this kind of work, not to create a bioweapon, but in order to understand these viruses, maybe to develop vaccines and treatments? It seems like a very, very logical possibility. And then, so we know that the Wuhan Institute of Virology had all of the skills. We know that they were part of this proposal. And then you have Peter Daszak, who knows all of this. And at that time, in February of 2020, we didn't know. But then he comes swinging out of the gate saying anybody who's raising this possibility of a lab incident origin is a conspiracy theorist. I mean, it really makes him look, in my mind, very, very bad. And
not to at least be somewhat open-minded on this, because he knows all the details. He knows that it's not 0%. I mean, there's no way in his mind to even argue that. So it's potential because of the bias, because of your focus. I mean, it could be the Anthony Fauci masks thing, where he knows there's some significant probability that this is happening, but in order to preserve good relations with our Chinese colleagues, we want to make sure we tell a certain kind of narrative that's not really lying. It's doing the best possible action at this time to help the world. Not that this already happened.
Yeah.
But that's how,
I think it's quite likely that was the story that he was telling himself. But it's that lack of transparency, in my mind, is fraudulent. That we were struggling to understand something that we didn't understand, and that I just think that the people who possess that kind of information, especially when the existence, like the entire career of Peter Daszak is based on U.S. taxpayers, there's a debt that comes with that. And that debt is honesty and transparency. And for all of us, and you talked about your girlfriend checking your phone, for all of us, being honest and transparent in the most difficult times is really difficult. If it were easy, everybody would do it. And that's, I just feel that Peter was the opposite of transparent, and then went on the offensive, and then had the gall of joining, and we'll talk about this highly compromised joint study process with the international experts and their Chinese government counterparts, and use that as a way of furthering this, in my mind, fraudulent narrative that it almost certainly came from natural origins, and the lab origin was extremely unlikely.
Just to stick briefly on the proposal to wrap that up, because I do think, in a kind of Jon Stewart way, if you heard that so kind of like common sense way, the 2018 proposal to DARPA from Eco Health Alliance and Ohio Institute of Virology just seems like a bit of a smoking gun to me. Like that. So there's this excellent book that people should read called Viral, The Search for the Origin of COVID-19. Matt Ridley and Alina Chan. I think Alina is in MIT, probably the book. Yeah, at Broad Institute. Yeah. So she, I heard her in an interview give this analogy of unicorns. Yeah. And where basically somebody writes a proposal to add horns to horses. The proposal was rejected, and then a couple of years later, or a year later, a unicorn shows up
in the place where they're proposing to do. I mean, that's so I had.
And then everyone's like, "Yeah, it's natural origin." Yeah. It's like it's possible it's natural origin. Like we haven't detected a unicorn yet. This is the first time we detected a unicorn, or it could be this massive organization that was planning, is fully equipped, has like a history of being able to do this stuff. That's the world experts to do it. Has the funding, has the motivation to add horns to horses. And now a unicorn shows up and they're saying, nope, definitely not.
Well, that connects to what your first question of how do I get to my 85%? And here's a summary of that answer. And it's what I said in my 60 minutes a long time ago. Of all the gin joints in all the towns in all the world, the quote from Casablanca. And so of all the places in the world where we have an outbreak of a SARS-like bat coronavirus, it's not in the area of the natural habitat of the bats. It's in one city in China with the first and largest level 4 virology lab, which actually wasn't even using it. They were doing level 3 and level 2 for this work, where they had the world's largest collection of bat coronaviruses, where they were doing aggressive experiments designed to make these scary viruses scarier, where they had been part of an application to insert a furin cleavage site able to infect human cells, and where, when the outbreak happened, we had a virus that was ready for action to infect humans, and to this day better able to infect humans than any other species, including bats. And then from day one, there's this massive cover. And then on top of that, in spite of lots of efforts by lots of people, there's basically no evidence for the natural origin hypothesis. Everything that I've described just now is circumstantial, but there's a certain point where you add up the circumstances and you see that this seems pretty likely. I mean, if we're getting to 100%, we are not at 100% by any. There still is a possibility of a natural origin, and if we find that, great. But from everything that I know, that's how I get to my.
And we'll talk about why this matters, in a political sense, in the human sense, in a science, realm of science, all of those factors. But first, as Nietzsche said, let us look into the abyss and the games we play with monsters. That is colloquially called gain-of-function research. Let me ask the kind of political sounding question, which is how people usually phrase it. Did Anthony Fauci fund gain-of-function research at the Wuhan Institute of Virology?
So it depends. I mean, I've obviously been very closely monitoring this. I've spoken a lot about it. I've written about it. And it depends on, I mean, not to quote Bill Clinton, but to quote Bill Clinton, it depends on what the definition of is. And so if you use a common sense definition of gain of function, and by gain of function, there are lots of things like gene therapies that are gain of function, but here what we mean is gain of function for pathogens potentially able to create human pandemics. But if you use the kind of common sense language, well, then he probably. If you use the technical language from a 2017 NIH document and you read that language very narrowly, I think you can make a credible argument that he did not. There's a question, though, and Francis Collins talked about that in his interview with you. But then there's a question that we know from now that we have the information reports submitted by EcoHealth Alliance to the NIH, and some of which were late or not even delivered, that some of this research was done on MERS, Middle Eastern Respiratory Syndrome virus. And if that was the case, there is, I think, a colorable argument that would be considered gain-of-function research even by the narrow language of that 2017 document. But I definitely think, and I've said this repeatedly, that Rand Paul can be right and Tony Fauci can be right. And the question is, how are we defining gain of function? And that's why I've always said the question to my mind isn't was it or wasn't it gain of function, as if that's like a binary thing, if not grade, if yes, guilty. The question is just what work was being done at the Wuhan Institute of Virology? What role, if any, did U.S. Government funding play in supporting that work? And what rights do we all have as human beings and as American citizens and taxpayers to get all of the relevant information about that?
So let's try to kind of dissect this. So who frustrates you more, Rand Paul or Anthony Fauci in this discussion, or the discussion itself? So, for example, gain of function is a term that's kind of more used just to mean playing with viruses in a little lab to try to develop more dangerous viruses. Is this kind of research a good idea? Is it also a good idea for us to talk about it in public in the political way that it's been talked about? Is it okay that U.S. may have funded gain-of-function research elsewhere? I mean, it's kind of assumed, just like with Bill Clinton, there was very little discussion of, I think, correct me if I'm wrong, but, whether it's okay for a president, male or female, to have extramarital sex. Okay? Or is it okay for a president to have extramarital sex with people on the staff or her staff? It was more the discussion of lying, I think. It was, did you lie about having sex or not? And in this gain of function discussion, what frustrates me personally is there's not a deep philosophical discussion about whether we should be doing this kind of research and what are the ethical lines, research on animals and all. Those are fascinating questions. Instead, it's a gotcha thing. Did you or did you not fund research on gain of function? And did you fund, it's almost like a bioweapon, did you give money to China to develop this bioweapon that now attack the rest of the world. So, I mean, all those things are pretty frustrating. But is there I think the thing you can untangle about Anthony Fauci and gain of function research in the United States and Eco Health Alliance and Wuhan Institute of Virology that's kind of that's clarifying. Like, what were the mistakes made?
Sure. So on gain of function, there actually has been a lot of debate. I mentioned before in 2011 his first papers. There was a big debate. Mark Lipsitch, who's formerly at Harvard, now with the U.S. government, the president's office, he led a thing called the Cambridge Group that was highly critical of this work, basically saying we're creating monsters. They had the funding pause in 2014. They spent 3 years putting together a framework, and then they lifted it in 2017. So we had a thoughtful conversation. Unfortunately, it didn't work, and I think that's where we are now. So I absolutely think that there are real issues with the relationship between the United States government and Eco Health Alliance, and through that, Eco Health Alliance with the Wuhan Institute of Virology. And one issue is just essential transparency, because as I see it, it's most likely the case that we transferred a lot of our knowledge and plans and things to the Wuhan Institute of Virology. And again, I'm sure that Xu Li is not herself a monster. I'm sure of that, because I've never met her. But there are just a different set of pressures on people working in an authoritarian system than people who are working in other systems. That doesn't mean it's entirely. And so I absolutely think that we shouldn't give $1 to an organization, and certainly a virology institute, where we don't have full access to their records, to their databases. We don't know what work is happening there. And I think that we need to have that kind of full examination. And that's why, so I understand what Dr. Fauci is doing, is saying, hey, what I hear, Dr. Fauci saying, what I hear from you, Rand Paul, is you're accusing me of starting this pandemic, and you're using gain of function as a proxy for that. When there are Senate hearings, every senator gets 5 minutes, and the name of the game is to translate your 5 minutes into a clip that's going to run on the news. So I get that there is that kind of gotcha. But I also think that Dr. Fauci and the NIH, the National Institute of Allergy and Infectious Diseases, and the NIH should have been more transparent. Because I think that in this day and age, where there are a lot of people poking around in this whole story of COVID origins, we would not be where we are if it wasn't for a relatively small number of people. And I'm part of, there are two groups. One is these internet sleuths known as Drastic, and a number of them are part of a group that I'm part of called, it's not our official name, but called the Paris Group. It's about 24 experts around the world, but centered around some very high-level French academics. So we've all been digging and meeting with each other regularly since last year. And our governments across the board, certainly China, but including the United States, haven't been as transparent as they need to be. So there's definitely mistakes were made on all sides. And that's why, for me, from day one, I've been calling for a comprehensive investigation into this issue that certainly obviously looks at China. We have to look at ourselves. We did not get this right.
So I'm just going to put Rand Paul aside here.
Yeah.
Politician playing political games. It's very frustrating, but it is what it is on all sides. Anthony Fauci, you think should have been more transparent and maybe more eloquent in expressing the complexity of all of this, the uncertainty in all of this.
Yeah, and I get it's really hard to do that, because let's say you have you speak a paragraph, and it's got 4 sentences. And one of those sentences is the thing that's going to be turned to Twitter and
let me push back. I get really so. I'll try not to be emotional about this, but I've heard Anthony Fauci a couple of times now say that he represents science. I know what he means by that. He means in the political bickering, all that kind of stuff, that for a lot of people he represents science. But words matter, and this isn't just clips. I mean, maybe I'm distinctly aware of that doing this podcast. Like, yeah, I talk for like hundreds of hours now, maybe over 1,000 hours. But like, I'm still careful with the words. Like, I'm trying not to be an asshole, and I'm aware when I'm an asshole, and I'll apologize for it. Like, if the words "I represent science" left my mouth, which they very well could, I would sure as hell be apologizing for it. And not in a because I got in trouble. I would just feel bad about saying something like that. And even that little phrase, "I represent science." No, Dr. Fauci, you do not represent science. I love science. The millions of scientists that inspired me to get into it, fall in love with the scientific method and the exploration of ideas, the rigor of science. That Anthony Fauci does not represent. He's one, I believe, great scientist of millions. He does not represent anybody. He's just one scientist. And I think the greatness of a scientist is best exemplified in humility. Because the scientific method basically says, like, you're like standing before the fog, the mystery of it all, and like slowly chipping away at the mystery. And it's like it's embarrassing. It's humiliating how little you know. That's the experience. So the great scientists have to have humility to me, and especially in their communication, they have to have humility. And I mean, I don't know. And some of it is also words matter because you have to, like, great leaders have to have the poetry of action. They have to be bold and inspire action across millions of people. But you also have to, through that poetry of words, express the complexity of the uncertainty you're operating under. Be humble in the face of not being able to predict the future or understand the past or really know what's the right thing to do, but we have to do something. And through that, you have to be a great leader that inspires action. And some of that is just words. He chose words poorly. I'm all torn about this. And then there's the politicians that are taking those words and magnifying them and playing games with them. And of course, that's the disincentive for the people who do, the scientific leaders that step into the limelight to say any more words. So they kind of become more conservative with the words they use. I mean, it just becomes a giant mess, but I think the solution is to ignore all of that and to be transparent, to be honest, to be vulnerable, and to express the full uncertainty of when you're operating under, to present all the possible actions, and to be honest about the mistakes they made in the past. I mean, there's something, even if you're not directly responsible for those mistakes, taking responsibility for them is a way to win people over. Like, I don't think leaders realize this often in the modern age. In the internet age, they can see through your bullshit, and it's really inspiring when you take ownership. So do the thought experiment, like in public, do a thought experiment. If there was a lab, and then lay out all the funding for the Health Alliance, all the incredible science going on at the Wuhan Institute of Virology and the NIH. Lay out all the possible ethical problems. Lay out all the possible mistakes that could have been made. And say, like, this could have happened, and if this happened, here's the best way to respond to it and to prevent it in the future. Just lay all of that complexity out. And I wish we would have seen that. And I have hope that this conversations like it, your work, and the books on this topic will inspire young people today when they become in Anthony Fauci's role to be much more transparent and much more humble and all of those kinds of things. That this is just a relic of the past when there's a person, no offense to me, in a suit that has to stand up and speak with clarity and certainty. I mean, that's just a relic of the past. It is my hope. But
would you mind if I have?
Yeah.
Because I agree with a great deal of what you you said, it's really unfortunate that certainly the Chinese government, as I said before, our government wasn't as transparent as I feel they should have been, particularly in the early days of the pandemic, and particularly with regard to the issue of pandemic origins. And we know that Dr. Fauci was on calls with people like Christian Anderson and Scripps and others in those early days, raising questions. Is this an engineered virus? There were a lot of questions. And it's kind of sad. I mean, as I mentioned before, I've been one, and certainly there were others, but there weren't a lot of us, of the people from the earliest days of the pandemic were raising questions about, hey, not so fast. Here, and I launched my website on pandemic origins in April of last year, April 2020. It got a huge amount of attention. And actually, my friend Matt Pottinger, who was the Deputy National Security Advisor, he was reaching out to people in the U.S. government and allied governments saying, hey, we should look into this. What he was sending them was my website. It wasn't some U.S. government information. And so,
by the way, people should still go to the website. You keep getting it, keep updating it, and it's a incredible resource.
Thank you, Jamie. That's a record. And it's really unfortunate that our governments and international institutions, for pretty much all of 2020, weren't doing their jobs of really probing this issue. People were hiding behind this kind of false consensus. And I'm critical of many people. Even when I heard Francis Collins' interview with you, I just felt, well, he wasn't as balanced on the issue of COVID origins. Certainly, Dr. Fauci could have, in his conversation with Rand Paul, it wasn't even a conversation, but in some process of the aftermath, could have laid things out a bit better. He did say, and Francis Collins did say, that we don't know the origins, and that was a shift, and we need to have an investigation. So now, but having said all of that, I do kind of, one, I have tremendous respect for Dr. Fauci, the work that he's done on HIV/AIDS. I have been vaccinated with the Moderna vaccine. Dr. Fauci was a big part of the story of getting us these vaccines that have saved millions and millions of lives. And so I don't think, I mean, there's a lot to the story. And then the second thing is it's really hard to be a public health expert because you have your mission is public health. And you have to, if you are leading with all of your uncertainty, it's a really hard way to do things. And so, like even now, if I go to CVS and I get a Tylenol, somebody has done a calculation of how many people will die from taking Tylenol, and they say, well, we can live with that. And that's why we have regulation. And so all of us are doing kind of summaries. And then we have people in public health who are saying, well, we've summed it all up, and you should do X. You should get your kids vaccinated for measles. You should not drive your car at 100 miles an hour. Don't drink lighter fluid. Whatever these things are, and we want them to kind of give us broad guidelines. And yet now our information world is so fragmented that if you're not being honest about something material, someone's going to find out, and it's going to undermine your credibility. I agree with you that there's a greater requirement for transparency now. Maybe there always has been, but there's an even greater requirement for it now because people want to trust that you're speaking honestly. Yeah. And that you're saying, well, here's what I know, and this is based on what I know. Here are the conclusions that I draw. But if it's just, and again, I don't think the words "I'm science" or whatever it was are the right words. But if it's just, trust me because of who I am, I don't think that flies anywhere.
Can I just ask you about the Francis Collins interview that I did? If you got a chance to hear that part, I think in the beginning we talked about the lab leak. What are your thoughts about his response? He said it's within the investigation, but I mean, I don't know how you would interpret it. See, it's funny because I heard it in the moment as a great for the head of an age to be open-minded on this.
Yeah.
But then the internet and Mr. Joe Rogan and a bunch of friends and colleagues told me that, yeah, well, that's too late and too little.
Yeah. So first, let me say I've been on Joe's podcast twice, and I love the guy, which doesn't mean that I agree with everything he does or says. And on this issue, and I'm normally a pretty calm and measured guy, and when you're just out running with your AirPods on and you start yelling into the wind in Central Park, nobody else knows why you're yelling. But
So that you had such a moment?
I had a moment with Collins. And again, Francis Collins is someone I respect enormously. I mean, I live a big chunk of my life living in the world of genetics and biotech. And my book, Hacking Darwin, is about the future of human genetic engineering. And his work on the Human Genome Project and so many other things have been fantastic. And I'm a huge fan of the work of NIH. And he was right to say that the Chinese government hasn't been forthcoming and need to look into it. But then you asked him, well, how will we know? And then his answer was, we need to find the intermediate host. Remember I said before? And so that made it clear that he thought, well, we should have an investigation, but it comes from nature, and we just need to find that, whatever it is, that intermediate animal host in the wild, and that'll tell us the story.
So he already had the conclusion in mind, and they're just waiting for the conclusion.
That was my, I felt like he was,
and that was
tilting
frustrating
in general, but he was tilting, and my dear friend was, where do I fall? He was like, I'm 85% or whatever it is, 80, 75, 90, whatever it is, in the direction of the lab incident. It made it feel that he was 90-10 in the other direction, which is still means that he's open-minded about the possibility. And that's why, in my view, every single person who talks about this issue, and the right answer, in my view, is we don't know conclusively. And this is my personal view, the circumstantial evidence is strongly in favor of a lab incident origin, but that could immediately shift with additional information. We need transparency, but we should come together in absolutely condemning the outrageous cover-up carried out by the Chinese government, which to this day is preventing any meaningful investigation into pandemic origins. We have, if you use the economist numbers, 15 million people who are dead as a result of this pandemic. And I believe that the actions of the Chinese government are disgracing the memory of these 15 million men. They're insulting the families and the billions of people around the world who have suffered from this totally avoidable pandemic. And whatever the origin, the fact the criminal cover-up carried out by the Chinese government, which continues to this day, but most intensely in the first months following the outbreak, that's the reason why we have so many dead. And certainly, as I was saying before, I and a small number of others have been carrying this flame since early last year. But it's kind of crazy that our governments haven't been demanding. We can talk about the World Health Organization process, which was pretty compromised in the beginning. Now it's become much better. But again, it was the pressure of outsiders that played such an important role in shifting our national and international institutions. And while that's better than nothing, it would have been far better if our governments and international organizations had done the right thing.
If I could just make a couple of comments about Joe Rogan. So there's a bunch of people in my life who have inspired me, who have taught me a lot, who I even look up to. Many of them are alive, most of them are dead. I want to say that Joe said a few critical words about the conversation with Francis Collins. Most of it offline, but a lot of great conversations about it. Some he said publicly, and he was also critical to say that me asking hard questions in an interview is not my strong suit. And I really want to kind of respond to that, which I did privately as well, but publicly, to say that Joe is 100% right on that. But that doesn't mean that always has to be the case. And that is definitely something I want to work on. Because most of the conversations I have, I want to see the beautiful ideas in people's minds. But there's some times where you have to ask the hard questions to bring out the beautiful ideas. And it's hard to do. It's a skill. And Joe is very good at this. He says the way he put it in his criticism is, he does this in his conversation, which is, whoa, stop. There's a kind of sense like, did you just say what you said? Let's make sure we get to the bottom and clarify what you mean. Because sometimes really big, negative, or difficult ideas can be said as a quick aside in a sentence. Like it's nothing. But it could be everything. And you want to make sure you catch that and you talk about it. And not as a gotcha, not as a kind of way to destroy another human being, but to reveal something profound. And that's definitely something I want to work on. I also want to say that, as you said, you disagree with Joe on quite a lot of things. So for a long time, Joe was somebody that I was just a fan of and listened to. He's now a good friend. And I would say we disagree more than we agree. And I love doing that. And but at the same time, I learned from that. So it's like a duel. Like nobody in this world can tell me what to think. But I think everybody has a lesson to teach me. I think that's a good way to approach it. Like whenever somebody has words of criticism, I assume they're right and walk around with that idea to really sort of empathize with that idea because there's a lesson there. And oftentimes, my understanding of a topic becomes is altered completely, or it becomes much more nuanced, much richer from that kind of empathetic process. But definitely, I do not allow anybody to tell me what to think, whether it's Joe Rogan or Theodore Dostoevsky or Nietzsche or my parents or the the proverbial girlfriend, which I don't actually have. Like all the
But you still busted my balls.
exactly. In my imagination, I have a girlfriend in Canada. But, yeah, that I have imagined exactly imagined conversations. I still want to mention that, but also I don't know if you've gotten a chance to see this. I'd love to also mention this Twitter feud between two other interesting people, which is Brett Weinstein and Sam Harris, or Sam Harris and others in general. And it kind of breaks my heart that these two people I listen to that are very thoughtful about a bunch of issues. Let's put COVID aside. People are very emotional about this topic. I think they're deeply thoughtful and intelligent, whether you agree with them or not. And I always learn something from their conversations. And they are legitimately, or have been for a long time, friends. And it's a little bit heartbreaking to me to see that they basically don't talk in private anymore. And there's occasional jabs on Twitter. And I hope that changes. I hope that changes in general for COVID. That COVID brought out I would say, the most emotional sides of people, the worst in people. And I think there hasn't been enough love and empathy and compassion. And to see two people from whom I've learned a lot, whether it's Eric Weinstein, Brett Weinstein, Sam Harris, you can criticize them as much as you want, their ideas as much as you want. But if you're not sufficiently open-minded to admit that you have a lot to learn from their conversations, I think you're not being honest. And so I do hope they have those conversations. And I hope we can kind of I think there's a lot of repairing to be done post-COVID, of relationships, of conversations, and I think empathy and love can help a lot there. This is also just I talked to Sam privately, but this is also a public call out to put a little bit more love in the world, um, and for these difficult conversations to happen. Because Brett Weinstein could be very wrong about a bunch of topics here around COVID, but he could also be right. And the only way to find out is to have those conversations. Because there's a lot of people listening to both Sam Harris and Brett Weinstein. And if we go into these silos where you just keep telling each other that you're the possessors of truth and nobody else is the possessor of truth, what starts happening is you both lose track or the capability of arriving at the truth because nobody's in possession of the truth. So anyway, this is the call out that we should have a little bit more conversation, a little bit more about it.
Totally agree. And both of those guys are guys who I respect. And as you know, Brett, and again, as I mentioned, just a handful of us were the early people raising questions about the origins
That's right.
of this pandemic. Right.
He was there also talking.
Yeah.
Like people have heard him speak quite a bit about antiviral drugs and all that kind of stuff. He was also raising concern about that ego down.
Yeah, exactly. And so, but I completely agree with you that I don't have to agree with everybody, but it's great to have healthy conversations. That's how we grow. And absolutely, we live in a world where we're kind of, if we're not careful, pushed into these little information pockets. Certainly on social media, I have different parts of my life. One is focusing on issues of COVID origins, and then I have genetics and biotechnology, and then I have, maybe we'll talk about later, One Shared World, which is about how do we build a safer future. And when I say critical things like the Chinese government, we have to demand a full investigation into pandemic origins, this is an outrage, then it's really popular. When I say, let's build a better future for everyone in peace and love, it's like, wow, 3 people liked it, and one was my mother. And so I just feel like we need to build, we used to have that connectivity just built in because we had these town squares and we couldn't get away from them. Now we can get away from them. So engaging with people who have a different background is really essential. And I'm on Fox News sometimes 3-4 times a week, and I would, in my normal life, I'm not watching that much of Fox News or even television more generally. But I just feel like if I just speak to people who are very similar to me, maybe it'll be comfortable. But what have I contributed? So I think we really have to have those kinds of conversations and recognize that at the end of the day, most people want to be happy, want to live in a better world, and maybe have different paths to get there. But if we just break into camps that don't even connect with each other, that's a much more dangerous road.
Let's dive back into the difficult pool.
Yes.
Just like you said, in the English-speaking world, it seems popular, almost easy to demonize China, the Chinese government, I should say. But even China, like there's this kind of gray area that people just fall into, and I'm really uncomfortable with that. Perhaps because in my mind, in my heart, in my blood, are echoes of the Cold War and that kind of tension. It feels like we almost desire conflict, so we see demons when there is none. So I'm a little like cautious, demonized, but at the same time, you have to be honest. So it's like honest with the demons that are there, and honest when they're not. This is kind of a geopolitical therapy session of sorts. So let's keep talking about China a little bit from different angles. So let's return to the director of the Center of Emerging Infectious Disease at the Wuhan Institute of Virology, Xi Jinping, colloquially referred to as Batwoman. So, do you think she's lying?
Yes.
Do you think she's being forced to lie?
Yes.
I've known a bunch of virologists in private and public conversation that respect her as a human being, as a scientist. As a scientist,
Yeah.
not a human being. I think they don't know the human, they know the scientist. And I respect her a lot as a scientist.
Yeah, I respect her. I've never met her. We had one exchange, which I'll mention in a second, in a virtual forum, but I do respect her. I think that she is somebody who has tried to do the right thing. She was one of the heroes of tracking down the origins of the SARS-1, and that was a major contribution. But as we talked about earlier, it's a different thing being a scientist, or really kind of anything. It's different being one of those people in an authoritarian society than it is being in a different type of society. And so when Shi Jinping said that the reason the WIV database was taken offline in September 19 was because of computer hacks, I don't think that's the story. I don't think she thinks that's the story. When I asked her in March of 2021, March of this year, in a Rutgers online forum, when I asked her whether the Chinese military had any engagement with the Wuhan Institute of Virology in any way, and she said absolutely not, paraphrasing, I think she was lying. Do I think that she had the ability to say, well, either one, yes, but I can't talk about it?
How'd you find out about me? On the phone? Oh, somebody randomly called you. I'm just going to get a Zoom link. Sure. I stream at like 24 hours a day, 7 days a week, 365 days a year for work week. I've been doing so for like 2.5 years. Yeah. Well, it gives me a platform to be able to discuss what these things like ending world hunger through the use of technologies such as agricultural drones, building greenhouses, saltwater greenhouses, vertical farming, hydroponics, cloud seeding. These are all ideas that I think are positive for the world that are being discussed with the focus. Exactly. So that's what I do. Currently watching a podcast on AI, the Lex Friedman podcast. Have you heard of it? Excellent. Just enjoying life. How about you? What's new in your network? Very cool. What video game? Actually, these are all available on Wikipedia. There's nothing necessarily suppressed about them.
So, like, an example, medication that they can most of that for asthma, and this asthma medication has recently, they're saying that they've known about it, that this medication is responsible to cause severe depression in people. She lost some people who have killed themselves. I personally did 6 times the cycle of myself. So I feel like I lost my patient infection. And I just assumed so I'm very upset about making my infection even worse. I think I was getting in my hands or better.
Well, certainly.
I heard that to be honest with you. That's one of those
Yes, you are. Are you offered that medication? Are you offered that medication?
Yeah.
mainstream discussion, like anti-gravity, passive time travel, that kind of stuff. Yeah, well, as of right now, it's just really the Balthazar story, element one, between the use of okay. What ones do you like?
One thing that's like voice to skull technology.
Voice of God technology. Yeah, absolutely. That's fascinating.
Where they actually like a laser at someone's skull.
Absolutely.
That person will hear voice in their head.
100%.
Whatever they're going to say to them, they can change the voices with AI and turn it towards sounding like their voice, but they are responsible for the voice.
Correct. Yeah, that's a fascinating.
I think that I have seen an alien ship.
When was that? Tell me about it. I love hearing about these.
So, with that, really accurate, pretty extreme drug user.
What kind of drugs?
I was in rehab.
What kind of drugs? Okay.
Severe depression.
Right.
So, I ended up going with my wife to drug in the inpatient treatment center. I don't know where to imagine. I'm in the woods, I'm nothing about myself. And I'm realizing to be those experiences that people just have that big life experience living the same way, living lives. Pretty much got me open up today, but I don't know these dreams. Like, just on this guy that I'm watching, you just talk to him, get after the and then, so it's pretty much, conversation with this guy, but in that, just you said that you can access the sign or something. 2 seconds after that ship shoots across the sky in front of me. Crossing back around. There's no cloud in the sky. And well, you do myself. And at the same time, I also have to get to that message. What to say. Here,
Wild. What did the ship look like?
it was white. And it didn't have a tail. And you can contract that makes it itself a little bit.
Sure. So off the coast of New York's Long Island.
vaccination. And it was, a bunch of kids. And it's like the girl that was in Ori, who got shaved, treated like a, big, with the torturers that they talked about going through. Incredibly brother. And, yes, it's exactly ultra. The culture is very on. Sensory deprivation, extreme sensory overload, trauma, multiple personalities, structured minds, and become a super soldier, basically. They plan not to take control of their body or life at all, and look at them all as became a total avoided thing. Dropped into this trance from this forward into his personality that had been programmed with admission that the other personality doesn't know about very well. That was part of this is part of the technology program that was made between the government of exchange of technology that carefully raised in our time.
Yeah, you mean in 1954 or another time?
Yeah, I mean, there's a continuation of that basement. They were on top. They had a chair that they got out of a crash in a boat. This chair, supposedly, you could sit in it and it would just, and by telepathy, if sex, you dream of it with military, supposedly, they can manifest anything out of there with this. And this is also for them, but they were making portal, they were making portal into portal and go to a specific time on Earth. Then you would have these programmed the ultra people go to the portal, and then back in time, live a life and bring change. And that's amazing. Supposedly, my original timeline, the South won Confederate War has caused the United States to never recover. And this term caused the Nazis to be able to successfully win World War II.
This is similar to, it plays off of some things from, I believe, the Kid Brooks, the band, and the Mike Jackson.
I know of it. I was the story. Where it is.
Yeah, so it was made into an Amazon series. Basically, it's a story where alternative history becomes true, and Nazis take over basically the eastern part of the United States, and Japanese take on the western part of the United States. It just plays out like that.
So, most everything that I talk about also got is that the classification for what I talk about. So here's the side shadow of the video.
Correct. Too many people spamming and stuff, so
For the general that
no, it's people spamming. So you can send it to me in a message.
was the scientific explanation.
Nope, I'll send you. What is it? What you sent it to?
So this video causing was one of the operators of Contact who was training or something. They did the amateur and torture him. But he was unaware because he was also in the amateur victim as well. Just by looking in the room, you can see the technology that's like President Nichols died. He was responsible for some of the most advanced development of frequency technologies. And so, of course, he was of his later life.
How did you start to learn about this?
And what I'm also doing is just this test, to be honest, and it's short or strange. But certainly with it, and it is individual money actually gains for
It's video of one of those aliens. It's video of one of those aliens?
what I believe so, yes.
Alright. Yeah, send that to me. I'd love to look at it. Look at it right now.
I did. And so, while it's being married in a Nazi uniform, but
Yeah.
it seems to be talking to a group, and the camera behind the group, it is being to, and you see the thing shifting into a dinosaur. And I believe it's the videos taken inside the thing.
Okay, I'm watching it. It's very blurry, right?
So, it would be more than that because
No, I understand. I do too. Okay, so it looks like a guy in a hat with a mouth, but his face you can't really decipher what it is. But you're saying that could be because the distortion of time or whatever. So I get that. Yeah.
Very upset, right? So,
Is there sound to this video aside from the music that's playing?
what do you say?
Is there sound to this aside from the music playing in the background?
I was looking at this. Other you also see it, it's a version of this. It's a version of the thing. It's arms are right at the moment.
Alright, so 2 minutes and 40 seconds.
And that moment, you also
Yeah, it's on guard. Who's watching this? Who are these people watching this?
Rabbi Yusuf, and you will see him straight up shaped into an alien green, scary dinosaur head. Half a second, it's enough to see its eyes and see its giant scales. Exactly. And it makes sense. And in particular to me, like this being considered what is being leadership roles and their trying to influence the other things. When you get those, you just screenshot of restrictions and less.
I'm taking a look at it.
See the green head, see the big ass eyes.
You sent it to me?
Oh yeah.
I think it's
Okay, yes, that's what happened.
So this not so you get to see the barbarian and this is also how fucking scary these beings actually are. This is really difficult footage also of soldier, I think Russia, is being chased by the Americans. The footage is being taken from an exact helicopter that's watching the damage and goes and after the dog gets ripped apart, you hear the power of the helicopter around it. And also just so much about the data that it takes so much money to recreate this accurately, especially with the thermal camera and that shows up on the thermal camera.
just like edited.
Did you watch all day?
Yeah, I did.
So I watched a lot of that, and I sent that footage to the military people. It would take a lot. I mean, honestly. So I think the most damning about this is that supposedly this footage, when you get down to it, you find that handles or any source of it, supposedly it was released for a random video game in Russia, survival horror video game. And but the thing is, when you think about the amount of money that would be taken to make this video, to have the helicopters, to have the blood, to have the anchors, to have everything, that's a lot of money to see if recreate that. That's the video game that was supposed to be from is a very small team of people that would never be able to afford to make a commercial like that.
Well, wait, they're making a video game, so they're like experts in video editing, right?
No, they're experts in coding and making games.
Yeah, but I mean, they're similar fields.
And it's just sort of, it showed exactly what I wanted. Who's ever that with these videos talks about is they got our flesh. We take violence, the elements, they will look at it.
Okay, so I frankly somewhat agree with you on that. What do you know about Dolce Base?
Sounds terrifying.
Yeah, tell me all about it. Tell me all about it.
Basically, an active play base in the plateau mountain. In Dulce, New Mexico.
Archuleta Mesa.
What is that?
Archuleta Mesa. That's what it's known as.
Yeah. People are just saying there's 6 ships flying down.
Right.
There's Phil Corso, Phil Snyder. One, what is a an engineer for the military.
Right.
And he was the one who describes having an underground battle with Greys
That's
discovered
exactly right.
during operations without the United States' knowledge. And there was a shootout and that began the war against the Greys, the killings.
That's exactly right.
Us began the war.
Right. So why don't you think that people go there, like they went to Area 51 before it was declassified?
She's still living over here.
So you know how people used to go to Area 51 and just camp out and watch stuff? Why don't people do the same there?
Okay, yeah, like how always are.
Yeah.
You see, you have friends that do that.
No, I don't have friends who do it. Well, I mean, kind of. I was before he died. I had correspondence with John Lear, but I mean, my friends don't actively do it.
You spoke to John there.
We exchanged emails like 15 years ago. I'm like I'm a big advocate of godless art, and I think that he speaks the truth. I think that he
John Lear is what about his album was
they're both very important. And there was there was this disagreement between so Bob Lazar had two people of that story. Well, there's Bob Lazar, George Knapp, the television host, but then there's John Lear is an important part of that story, and Gene Huff, and basically just I went and I read and listened to John Lear's side, and I listened to Gene Huff's side, and I just one day was like, I don't like how John Lear is being portrayed. So I looked up his email. It was just available on like some forum, and I just emailed him, and I said, "Hey, I just want you to know that like I'm the third party in this, and I don't have any dog in this fight. I'm just someone who's just researching, and I want you to know that I think that you were right and that you were portrayed erroneously." And he emailed me back right away. And he was like, "Thank you so much. You made my day. Yeah, it's just one of those things that you can't really control the narrative, but I appreciate that you reaching out." He was really nice. Yeah. So I am someone who, if I had the time and money and everything, I would just camp out at the Archuleta Mesa and see what's going on. But as I understand, it's not that easy. It's on tribal. It's on tribal land, so you can't just like go there. And it's like in one of the most least populated areas of the United States, and so it's just not super easy to get to. And absolutely, well, we're talking about two different places. One's in Nevada, the other's in New Mexico. Okay, yeah. So, I mean, those blast craters are all throughout the Nevada test site.
What do you know about the secret space program?
That's a great question. I know that one exists. That, in my opinion, NASA is just a front. It's a waste of time and money. I don't believe anything that they put out. And but there is real technology that we've gleaned from crashes such as the crash in Corona, aka Roswell. And I mean, allegedly, there was like an exchange of technology multiple times during the Eisenhower administration at Edwards Air Force Base, and then another Air Force base in New Mexico. And that's how we were able to. Um, yeah, Eisenhower's granddaughter or something like that, right?
She was actually going to secret space program and even money.
Well, I don't know about that, but I do know that she's been interviewed on that Coast to Coast AM. Do you know what Coast to Coast AM is?
Yeah.
Okay, great. I listen to it every night. I've been listening to it every night for years. And I've called it Get On Track. And but in terms of that story, there's something, I don't know to believe it, but it's fascinating to me. Do you know about Project Serpo? Okay, so allegedly, after this exchange of information that happened in the 60s, or I'm sorry, in the 50s, and like there was that we would allow these aliens to do experiments on people, like alien abductions, and in exchange we would get technology. And it was supposed to be a limited amount of people, but the aliens would respect the contract or the treaty and they just take whoever they like. Anyway, um, there was there was this alleged fraud program called Project Circle that took, I believe, 13 people, men and women, to um, another planet. Um, but like in another solar system, I believe it's called Circle. And the people, and the people, yeah, I think it was 3 years. And they brought all this. Well, no, some of them did. Some of them stayed, and some of them came back, and some of them died there. But as I recall, it was like 13 people. They brought all kinds of like, they brought like a bunch of food, and like they brought jeeps and things, and like a lot. They brought like a lot of stuff, and it was loaded onto some kind of like mothership somehow. And the mothership took them to this other planet, and the other planet was really interesting. That like they were introduced to people. It was very class system. Like they were workers, and then there was this elite class that they never got to meet. But basically, the story goes that there were like 13 guys. They had one leader of this like team, and they were to experience what life was like on another planet. They got very sick after getting there because of I thought it was the different gravity or something. The gravity was like a little stronger than yeah. And yeah, they had like very beautiful looking food, but it was disgusting to them. So just about please tell me everything you know in bullet points about Project Circle and especially the interaction with the people on another planet. Right, here we go. It was a secret exchange program between the U.S. and extraterrestrials whom Denver recognized whom they called the evil. So it wasn't Circle, it was Denver. Supposedly related to the Roswell crash 1947 which aliens were said to have been recovered and survived the killing and allegedly helped the U.S. government establish communication with the contract. Official exchange took place in 1965 with 12 months away from officers, 12 months. 10 men, 2 women, and the second boarded even plant spaceship to their home planet Circle. Oh, it was Circle. Okay. The mission was meant to last for 10 years, but reportedly extended to 13 years. Not 13. Due to time discrepancies and travel on this thing. The journey and arrival. Travelers Circle took 10 months aboard an enemy craft. The craft used advanced propulsion that caused disorientation and health issues in team members. One member died en route, and another died soon after due to complications from the alien environment. Planet Circle, primary condition. Circle is said to orbit one of the Zeta-Reticuli stars, approximately 39 million miles away. Harsh environmental conditions. It has 2 suns, resulting in constant daylight and intense radiation. The average temperatures are often above 100 degrees Fahrenheit. Difficult terrain with limited flora and fauna. Native food was hard to digest for humans, causing malnutrition. The team relied on Earth-supplied food until it ran out. Atmosphere is breathable, but it caused long-term issues for some of the team members. Even society and culture. Events were described as peaceful, intelligent, and highly disciplined. Communicated through a form of telepathy or tonal language, partially translated through technology. Technologically advanced. They had spaceships formal non-period finding documents to be assigned note, no evidence of religion or crime. They lack a specific expression of emotional display, appear to prioritize duty and communicate with individuality. The human interactions and experiences on this report. The team maintained contact with parents for the first 3 years, but communication eventually broke down. The humans lived in special subjects built by the heathens. There were cultural misunderstandings and psychological stress due to isolation, pagan and time perception differences. One of the few team members integrated more fully with the Eben society because he did not wish to recruit more. The Eben was curious about human biology and behavior. He did not have an experiment on humans with two documented differences. The detailed logs according to mistakes. The return, 8 members returned to Earth in 1978. 2 had died on circular tree trail this day. The return trip took longer and was more complex than planned. The return team underwent intense debriefing and instructed others to strict secrecy. All returnees report they died due to radiation exposure, psychological trauma, or illness by the early 2000s. Controversially and disruptive, there's no verifiable evidence inside the plane and verifiable. Elements of the story resemble UFO lore, such as Roswell and post-time verification. Yeah, I mean, that's basically what we know.
Yeah. See, I think, I have videos of that, it's going to take tourists that we sometimes see those studies and other things. So, how did you go?
39.
36. I've heard that it didn't happen like something happened in your life.
Yeah, this was like 15 years ago, and I recorded it in the last 5 years on the farm website. But basically, I was just driving to work, and a plasma ball flew over my car, and it felt like intelligent. It didn't explode or anything. It was just like maybe the size of a beach ball. That was maybe like, yeah. Well, no. That's different. Ball lightning's different. This was in the middle. This was like in the evening, and it was not dark out. It was light. They're known as plasma balls, and they were very common around that time, around like 2013 or so. It wasn't the ship though. It wasn't that big. It wasn't that big. It wasn't that big. It wasn't that big. It was like a drone, but it was like the size of a beach ball, and just looked like a plasma ball. And I've seen them on video, and so I know like it's similar to what other people have been able to record. And it seemed intelligent, though it didn't communicate with me. Um, but it was basically another sun, but the sun was still in the sky. The sun was setting at the time, and this thing just flew right into my car into a subdivision. I just knew immediately that was not anything that we had on here. It was like foreign. 39. Oh, no. Apologies. No. I thought you asked me how old I am. No, it happened like 13 years ago. And for many years, yeah. So I wasn't a believer. I was a strict skeptic up until about 17 years ago. And then I saw Stephen Greaves' The Disclosure Project. And that is the thing that changed my mind. and on all of this stuff. And I just recognized that. Have you seen the disclosure project? No. There's one press conference. It's by Stephen Greer. It took place May 9th, 2001 at the National Press Club in Washington, D.C. Okay, so when I saw that, that is the thing that convinced me that we weren't alone. There was just an overwhelming amount of evidence that these people had, and that came as a bit of a shock. And I told everybody I knew about it, and um, I was like the first person in my family who really grasped the enormous idea that we weren't alone. And since then, people have been convinced, but then I remember being on a run in Fullerton, Kansas City, California, and I was looking at the sky, which I perfect blue sky, and I kept kind of like how you were like you asked for something to happen. I kept asking for it to happen, and it got happened. I mean, I was just like, come on, there's gonna be an alien, like, come out, let me grab it. And so I was a little disappointed. I mean, like I've done that, like I wanted to see something, basically what I'm trying to see. And I had periods in my life where I like actively tried to see things and I could not. But then this one day I was not expecting it. I was just driving and distinctly right over my car, and it was completely silent. It was like the size of a beach ball. It was like orange, like the sun, but the sun was already in the sky, and uh, it moved like not like the sun. It moved like a beach ball being in the sky. Um, like I said, it was maybe 50 feet over my car, and when I got to work, I remember telling someone that this happened, and it was just like a wild thing. And I think this person maybe had some kind of encounter with themselves. I'm not exactly sure, but yeah, I just was like, I haven't necessarily felt my mind develop before. I've had times where I've been really, really stoned and felt like if aliens were going to communicate to me, that'd be a really great time for them to do it. And I really think there's something to that. If you're like really, really stoned, I think that you can have like almost like DMT, like released in your head, and just like with um, a DMT trip, like perhaps see or communicate with aliens or like beings or whatever. But I've had dreams, one in particular that like it, I don't know if it was alien.
What I think you saw was a no, it's plasma balls. Like how we use it for someone is operating them while I'm looking at the consciousness is in that ball. So that's what I think the intelligence that you're recognizing.
Yeah, I'm gonna do that. When you say someone, I think it was like the alien, not necessarily.
Which is really understanding for humans just for different planets too.
But then we get into defining what is it.
And so like there's two different kinds. I mean, there's like the dark black ships, and then there's the white bright ships, right? There's this one guy here, you're up on the other side with an alien in one scene, and he kicks it off, and you get over that, go out to his house,
Tell me about it.
and you look up his house.
Tell me what you know about it.
Himself after walking the woods, and he said it's possibly he came out to a being, and the being came out of nowhere and attacked him with a dog, and the man got thick and bashed it over the being's head, and the being got his own handed. And so he gets back to his house and he starts filming. And the being, I mean, you can tell that he is incredibly upset and very adrenaline pumping in his hands. He's covered in the camera. And he wakes up and is like, first time, and he's screaming and stuff. And you see, he's trying to interact with it and everything.
Did you say there's video of this?
Yes, I'm trying to pull it up. Here it is. Honestly,
Where did this take place?
As soon as you search on Google, you'll see the images.
I understand. All my stuff's free.
Here's the little video of in your DMs. Before he should say, like, you can see he's hearing you breathing and getting upset and really just sounding just got out to fight for his life. Just ready to strike.
Hold on. Did you send me something with like guys with like a machine gun? Ew. Oh, what's the thing with the machine gun? The man gets chased and rips apart.
Yeah, it's the footage of the soldier going around everybody.
Hold on, let me watch that.
That's what I was.
Is this the Russian thing? Okay.
particularly was that with information about the and different kind of was some of the key things that convinced me. It's authenticity.
Well, the thing with the thermal, it's not.
You can see that, right? It shows up. Yeah, it shows up.
Yeah, but I mean, I'm just like, why would like usually if I hear about reptilians, they're really big. So those things look like just humans running towards the sky. And
There's a lot of different species of reptilians.
hey, and I'm down for that. I mean, that's, space is a big place. Um, this one that I'm looking at now with the guy with the thing on the head.
But the operation is pretty intense. That is a classic negative prey. Evil understands analysis and weakness beyond our emotion.
And would you say feed off of a what?
We call other mental brain waves that we emit when we're going to torture each
LUSH?
LOOSH.
And they eat that?
That is what they've been reading on this. They are negative beings. Negative frequencies, low frequencies, or low frequency negativity is not good for them. So, torment and torture or is not good. But I think that's what other intelligence are. And my head is quiet. So, usually, I'll always say that we do it at the end of the day is their reception with demonology and understanding perception. That's just
What's the difference between a demon and an alien?
very little. But
How did you find this thing? You just received a random call in Discord? You received a random call in Discord from whom?
secrets, fallen, so demons.
Oh, yeah. Okay, cool. I know who that person is.
It's very random. We don't have one still very common. Now when I see the conversation that we're having, I understand why it happened. That phase works in Discord and anyways.
Yeah, that person found out about me, I think, of Pinterest, which is like, I don't even do anything on Pinterest. Okay, so the guy who knocked us eating out in the head, what happened to him? The Reed guy.
Look up the person got go and that's such Jonathan Reed and footage should also be able to find pictures of the alien ship and there's also further footage of when the alien wakes up and interacting with it.
Okay, what happened?
I think it's still alive. He got a advanced piece of technology from the Navy that has regular television show and it is incredibly advanced measured case. He said when you put this voice technology on, um, there's footage of it and also that I've seen when he puts it on, that these two spikes in this bracelet thing and with spikes in your arm and it turns into a white plasma cord and it gets really crazy and they have to wanted to go together. But yeah, you can only be 6 sharp with it. But you just have to interact with them correctly. Transport correctly. Pretty much you and invested by deciding it's going to happen in your own mind. And it's pretty cool. It's interesting. Maybe last night, it's give an example. I intended to see spirits sitting in the clouds, faces in the clouds, and as soon as I said I intend to see the face of the cloud, immediately I see an incredibly detailed face in the cloud. That was pretty cool.
What kind of face? Male or female?
I have a lot of synchronicities in relationship to the more intense one that has happened to me recently was I go on one once, maybe 8 miles, 6 mile walk.
That is a long one. What's that take? What's that take you? Like 2 hours?
Just really long time. I've also really history.
Good on you, man.
So that's the thing.
Even better.
That's the thing. After fully like going full fledged with this alien stuff, and accepted totally, my life has changed for the better significantly everywhere.
seems that way. So you saw a face in the cloud yesterday?
Yes, it was speaking of that. It's an example of what you're going to do. I'm trying to teach you how you can practice these things. Is just look up in the sky. You can say, well, I don't know what you're thinking. You can kind of investigate. You really don't want to be this taught. And you will understand the answer. So it's, before Trump was elected, I've been waiting for this for a long time. This actually going to happen. It's Hollywood actually going to collapse. We're going to change it. I'm going to really think about this. It's my dream to wait this for so long. And immediately after that, I looked and I see the horizon and the tree. This tree has leaves. It's fall time, so most leaves are gone. But the last few years that are in this tree are making it perfect. One, a square one, and a square two. And this square, it was bizarrely perfect. Square and everything in the middle of this tree up there. And I was going to try and take a photo of it, but I mean, take a few steps and it disappeared. So then I got home and I asked the AI, what is symbology of the number 12? And I got that it is divine learning. And it was the answer to that question, saying that yes, basically, everything what it needs to. And nutrition, it did happen. So,
Do you know any abductees?
I did. I don't know what the answer is to my said it was abducted when he was pretty long ago.
And what was his experience?
He had implants that you could feel inside wires, squares.
What was the first word you said? Wires?
He had implants that they had put into him.
Yeah, and then you said something and squares. What was the word something?
The wire,
Oh, okay.
but not the wire.
And had he gone up in a craft?
I don't know what the name was. So, I don't ask what.
What happened?
I've seen multiple actually. But the one time was so incredibly definite. Like, legit.
What'd you say?
I've had other times where he's like, it's definitely not happening. Strange, but nothing is weird as I was intrigued on the scene that shot across the sky.
So you think you can bring these things with your mind?
Everything happens. This is how it works. This is how everyone's doing this. You know, see,
Please elaborate.
The Stephen Greer's
Yeah. I know that.
it's basically anyway. It's, this is how the disclosure of the alien divination where they're planning is going to work. It's not. There's never going to be one government explaining, telling everyone, hey, I'm going to do it. How they're going to carry as a person. They're going to, show up to pretty much what. But also we have to make it just be pleasant in your mind and make an invitation to what it comes.
You mean inviting?
Stephen Greer says, this is what I'm going. Stephen Greer, CD5, talks about how it's good to do this with a group. There's a lot of footage of shit happening. Anybody saying that if there's one person in the group that has scared frantic thoughts, it will, the beings will feel those scared frantic thoughts and want to work with you.
Right. I don't know why people don't find Stephen Greer credible. Why do you think?
Open adults, but you know, people don't, in general, don't want to be excluded. They don't want to be super out, don't want to be in my position, basically.
What's your position?
Explain to people on Earth that things are here. This,
Have you ever seen one?
I've seen, I've seen things even before, Other than that, I never figured it out. And I just look back at it, Trump is one, and Trump is one. But also, one of the comrades,
You think Donald Trump is an alien?
that's it's,
You think Donald Trump is an alien?
you know what a statue is?
Yeah, these people who are have
Just those souls from different galaxies who have made the decision to meet up with their mission. And it lives on it, and it provides itself and their souls forever. And we can take an investment. So it's a investment. It's like demons. I asked for about that between Jupiter and Saturn. It's funny, people have kind of questioned.
Hold on. Mars and Jupiter. Hold on. It's Mars and Jupiter.
Yeah, there's a planet in between that was explored. A lot of people who are living on Earth live on that planet. And supposedly that explosion of that planet is what destroyed Mars and melted away its atmosphere and civilization that was on the surface of Mars at the time. Supposedly Mars, on the side of Mars that it was facing that planet, there is about 1/3 of its surface missing from that specific side of the planet because of the spinning back.
wouldn't we see that in Mars rotates?
They looked at interesting photos from Mars and the robots that are on here.
Yeah, I don't really buy them.
A lot of them do evidence of past civilizations, cities, and secret space programs. People talk about how there's still a current population of Mars.
Was that planet between Mars and Jupiter older or younger than Earth?
Older, supposedly there was a mass civilization also on Venus. I mean, Scientology is supposedly everybody is truth. Beliefs. Obviously, Scientology is evil, treats its members and cults do what they believe, but the Lord of the galaxy that we talk about is accurate.
So you think the Scientologist people are telling the truth?
Well, I think everyone's telling the truth, some lies. That's values. When demons work, they typically always to confuse you by giving you truths mixed with lies. So you believe and some particular things also. One of those things that I have not been able to connect is the existence of giants and their position on this whole picture of is it definitely evidence of the loss of science students freedom of life.
Right. That's why the Smithsonian Institution was founded.
It's really it's like almost like trying to make like it's as if the negative beings got to our planet on a radio there. Okay. It's atmospheric. That's not what I understand. The Nazis had no work with cults and black magic rituals and stuff. How they were doing that stuff,
Like the Vril Project, the Vril Society.
The Nazis were the first ones to make contact with extraterrestrial beings and native reptilians. This is going to cause the Nazis to develop the first civilization to have developed anti-gravity ships that was
Like the Nazi bell.
they dropped them over time. What's Saturn's belt?
Yeah, the hexagram.
Six hurricane. is more like to think what it takes to make that work is not. And I also that it's not to get hexagram, I think it's a square.
It, I misspoke. It's a hexagon. But you think it's a square?
Yes. It looks like a hexagon from a bird's eye view.
I don't follow. I mean, I know it looks like a hexagon from a bird's eye view.
You already.
Yeah, dude, I don't like it.
Very familiar with
Yeah. Yeah, I think in that one I'm aware.
So it is, you'll see this, you'll see black shapes from all over the time. The Jews, very strange, but this next thing is what I'm saying there. This is the typical thing they do in Israel, is when the Jews, they read and read the Bible, Talmud, they wrap leather on their fingers, and they have a huge
No,
leather.
no, I've got one right here. It's my tefillin.
They put it on the forehead.
Dog, I do it 6 days a week.
Tell me about that. What is it?
Well, generally a series of prayers that we say during something called chakras, which are morning prayers. And depending on your tradition, you have it either one time around your bicep and 7 times around your arm, 3 times around your bicep and 7 times around your arm. Make a shin, which is a Hebrew letter with the leather on your hand. You say a blessing the first time around your bicep and the second time once it's on your head. Within the box is a little scroll that has the Shema on it, which is a prayer that we have. Hear, O Israel, the Hashem is God, Hashem is one. Then we essentially make an extended version of the prayer that we pray with it. And there's another box that that's on your bicep that essentially protects the box that's on your bicep, and it should be pointed towards your heart. It's something we can do. The reason why we do it is to remind us that we were once slaves in Israel in bondage, and essentially we're relieved from that every morning after we're done. We were once slaves in Egypt. We were in bondage, and so we the song River to Babylon.
It's something about Jewish people and how they wish to go to the land.
Right? Right?
So, what is inside the tree? I'm sorry.
Well, firstly, are you talking about the Bony and River to Babylon song? Right? Yeah, it's good. To Rastafari song. Okay, so what? No, it's generally. Though it does have some influence from Judaism. It's not Jewish. Oh, Babylon. That's no. I thought you meant Rastafari. Oh, so yeah, Babylon does most certainly. I mean, we were in exile. Babylon is pretty close to modern day Vatican and was the capital of the Babylonian Empire, which destroyed the first temple of ours.
Yeah, so probably when you got 100% down, probably that you remember Zion.
Yeah,
It's
that's
in Zion for sure.
yeah, it is. So that's generally considered to be Jerusalem. It's technically like Mount Moriah.
There is the contraries away, that's the way Christ was show us the good song, the strange land. The wicked carries away captivity. Forever suppress the song, which we sing the Lord's song in the strange land. So I think it's the song is going to maybe it's out.
I mean,
Slaves that came out of the West Indies, we go back.
yeah, that's our story. The Rastafarian song is just a telling of that story.
Those I'm not too bad.
No, not at all. It's accurate. I thought you were saying that Rastafarian, you were asking is Rastafarianism related to Judaism. And generally, I think some aspect of it will.
The rest of the yeah, but that's considered. I was raised as a Catholic. I was in Catholic school. And, that school, we atheist who was very bright. And recently, within the past 5 years, Jesus Christ back in my life.
Okay.
God's protection.
All right. Well, glad you have something that makes you happy.
Like I said, it takes time to decide what something so it was that's really true. It's suicide. I understood exactly why. Um, and I believe now that I was oppressed by a powerful negative entity that was feeding on my life. Never in my life when I was younger would I ever had been able to not negative in the future would I made I would kill myself and now I'm going to kill myself and I'm more likely to do shit. I'm more likely my past thoughts.
That's okay. You should know that you've really made some great progress, especially in terms of changing your mental state and your body. So that's great.
You know, and to please don't take any of this personal. You see me very much a good person and enjoy myself talking to you. But I have a lot of criticism for the Jewish people.
That's cool.
That,
Join the club. A lot of people do.
and you know, throughout world history that the Jewish people have been exiled in other countries.
Yeah, it varies, but a lot of times people choose 146.
Mel Gibson says that he doesn't push up every time. So,
All right.
Mel Gibson's what he says. Because it's very offensive.
He's the front runner against Gavin Newsom for governor of California in 2026.
Yeah. I never did. I'll just went through that. I was raised in Kansas school. I was putting dirt and all stuff. I critically questioned it. Saw what he was reading. Questioned it. I must be like those people that's love going through particularly Christians who have left Christ love. I been through a lot. And then one fucked up thing though, there was saying that on the third day of working at a gas station, I was severely beaten by a very dangerous psychopath. In the hospital.
That's terrible. What happened?
It was the third day of working at a gas station. There was an employee who had an incredibly abusive and dangerous husband who had already had most of the employees there. I had been a lot growing up, and I am an extreme punk. You can say imagine the 80s, but just love punk rock and going against the grain. It ends up fighting against mentality models. But this man, there's a lot of psychopath stuff in the world today. It kind of bad just seems. I think these people are being used by demons. There's people are angry about people that are seeing the life. And this was when I was about 34 years old. I did do a lot at that point in my life. I'll see a lot of that. At the end of it, I did me with this group as hard as I could. Like he was kicking me with the face of the group.
Did you press charges against this guy?
He's script. He's running around with his sleep. He's supposedly like sleep.
Did they put a warrant out for him or something?
I was told. I was already told he was sued. I was speaking at gas stations. We were doing the review. $11,000.
It's better than that.
Just make my rock bottom of extreme drug use and severe depression and suicide.
Alright.
A lot of money.
Yeah, I mean, you're in a better spot now, so that's good.
That's the thing. To be this satisfied enlightened, mind like and to it, it's severe and have money to get from, you know,
Okay, why do you have to have that done?
no death. It's sort of about no death.
Oh, I know what it is.
Most of my life, I was a tough guy. I was a bigger guy, close to the line, so, you know, I was afraid to go to those that shit, you know, protecting my friends and whatnot. And this moment, you can prove it to me that I was not what I thought I was, And it's just hard to explain, I guess, honestly.
Okay.
Something that you wrote, you realize you forgot. And it is artificial mentality, or something. It's an excitement. It's like it's a submitting to reality.
Okay.
But it's like you're learning of everything. You have to learn the best just for your life. For years, like, where I could have a chance